Hello guys, can someone confirm if you're able to hear me?
Yes, sir.
Okay, we'll start in 2 minutes. We'll wait for more people to join. Okay, guys, are you able to see the screen?
Yes, sir.
Okay, we'll start now. So what were we doing in the previous class? I think we were doing an introduction to data structures, right? And we understood some basics of data structures. And then we also talked about algorithms. We did, okay, in data structures, we took a look at arrays and linked list, right? And we saw how different data structures can be used in different use cases. And there are situations where array would be more suitable, and there can be situations where linked list can be more suitable. So, and at this in the same line, we also took some understanding of graph data structure and how the same data can be organized in different ways. Again, depending on what is our use case, we will make a choice of a proper data structure. And how will we do that? We'll do that with our understanding of time complexity, space complexity. We also understood about algorithms, right? So algorithms are operations we can do on a data structure to solve a well-defined problem in finite number of steps, unambiguous steps. And we took an example of algorithm. We took a simple example of finding a duplicate number in a given array, and we figured out different approaches to solve the same problem, and then we analyzed all the solutions. Three solutions we took about their time complexity and space complexity, and we were able to compare them basis the time and space efficiency, right? All of you are able to recall, and then I think we concluded the discussion with an introduction to the big O, right? Big O notation. Is everyone with me so far till here? Anyone is having any questions or doubts?
Yeah, very.
Guys? Okay. If not, then we'll continue the discussion. So today's agenda is what I am thinking is that all of you are able to see the screen, right?
Yeah. So, can you
Okay.
give a little bit deep dive into the big O?
We'll talk about it. Okay. So today's idea is that I want to talk a little bit about time complexity. We'll do a little bit more understanding of time complexity. Okay. And we'll start our discussion about, so in time complexity, I told you some of the common big O's are, one is O of 1, and then we have O of n, and then we have O of n squared, and then we have O of log n, and we also have O of 1 O of n, and then let me write it, O of log n, and then O of n log n. This is big O. Okay, and then we have exponential like O of 2 to the power of n, or O of 3 to the power of n, or O of n cube, or we can have O of 2n factorial. These are considered to be very poor choices. Okay, so normally we will be very happy and we will be very uh, content if we are able to use these, because normally we will be using these. Okay, normally we'll come across O of n, O of log n, O of n squared, O of n log n. Okay, usually when we are learning about sorting, we will see O of n log n. Okay, otherwise this is the most common one which you will see, which is linear, and then this will be logarithmic. Okay, and this we will say this is quadratic. There can be others also. So if you are studying theoretically, then based on time complexity, there can be different problems where you will have root of n, n root of n, all those things. But normally for our use case, we will be coming across these when we are trying to solve problems. Okay, this is called as constant. Now, in terms of big O, what we learned was you calculate number of steps. Okay, how many steps you are getting, and then you remove the constants and you take the highest power, right? So suppose if you are getting the O of n as, suppose n cube plus n square plus n plus 14. Okay, so here you will simply ignore others and you will only consider the n cube because this is the biggest one. So we'll say this is O of n. There is a mathematical way also, but we are not getting into that. Okay, it's not needed. It's fairly intuitive. Based on intuition, we can do. Suppose it is 4n cube plus 3n square. Okay, so this also will be O of, this will be O of n cube. This will be O of n cube. Okay, if you are having, say for example, 4 times log n plus 3. So this will be what? This will be O of log. Okay, and if there is a fine, if there is a, if the number of steps are independent of n, okay, if it is independent of n, then we will simply say O of 1. This means independent of n, or we'll say this is constant. Okay, so what you have to do, you have to remove coefficients, remove constants, take the highest growing term and remove coefficients. Okay, so if you're coming across any code and there you are doing 2 iterations, okay, so you will say that I'm doing 2n, means 2n 2 times. If the array is having 5 elements, then I'm doing 10 iterations. If it is having 20 elements, I'm doing 40 iterations, so it is twice. So 2 of n also we will say it is O of n only. This coefficient we will remove. Okay, if you're having 2n plus 4, then also we will say this is O of n. If we say this is 2n square plus 3n plus 2, then we'll say this is O of n square, which is the highest growing term, which is n square. Okay, that we will decide. Is this clear?
Yes.
Okay,
Yes.
so we'll do some example of this. We'll take some example of this, and then we'll also try to write some code, and then we will start our discussion about arrays. Okay, so suppose if we are writing one loop, you tell me about what will be the complexity. Okay, so we'll try to solve one problem here. Okay, this is a common puzzle that you will see many times. It will be asked in fresher interviews. That suppose there is a building. Okay, suppose there is a building. What is happening to my lines today? I don't know. Okay, suppose there is a building, and a building is having 100 floors. Okay, and you are having a basket of eggs. Okay, and each egg, so there are 100 floors. Okay, and each egg can break from a given floor. It means that it is possible that in this basket of eggs, you take an egg, and it is possible that it breaks from the 15th floor. You throw it from the first floor, it will not break. You throw it from the second floor, it will not break. You throw it from the 14th floor, it will not break. But if you throw it from the 15th floor, it will break. And if it is breaking from the 15th floor, then obviously 16, 17, 18, 19, 20 till 100, from any floor it will break. Is the question clear? So you have to find out, and you have basket of eggs, in that you have infinite number of eggs. Okay, so how many steps it takes to find the floor from which the eggs will break? Can someone help me?
Yeah. So we can start with the center floor 50.
Okay,
So if the eggs don't break, then we can take the middle of 50 and 100. That would be 75.
okay,
So similarly, whichever lands, if let's say it breaks on 75, then we know for sure it is between 50 and 75. Then again we can take the middle of those.
so how many
Uh,
steps?
um, I have to calculate. Sir, you told which floor there's the
How many
starts
steps? Yeah.
breaking.
So how many steps? We don't know which floor. We are not interested in the floor, but we are interested in how many steps it will take you to
Three to
find the
four
floor.
steps. 3 to 4 steps.
Saif is saying
n
n by 2 steps. No, it will not be n by 2 steps.
3/4 steps.
n minus 1 by 2.
How n minus 1 by 2?
First we will divide the half of them,
Okay.
and then again divide the remains half of them. So
Okay.
if it's a break, in that case we come down. If it
Okay.
doesn't break, in that case we go.
The logic is correct, but how will it lead to n minus 1 by 2?
So somewhere we will find like n minus 1 by 2. So somewhere we will find like 17, 15th it doesn't break, and 17 it's breaking.
Hmm.
So in between 17 and
First, you
15th.
are having 100. Okay. This is a very important concept. This question is might feel a little bit off, but this is a very important concept. First, you are having 100 steps. Okay. So one person was saying he was correct. I will go to the middle. Okay. So you can imagine this 100 as an array of 0, 1, 2, 49, 50, till 99 and 100. Okay. So what I will do first, I will go to the 50th floor and I will throw the egg from there. It is possible that egg will break or it will not break. Or first, wait, before doing that, what is a brute force solution? What is a brute force solution?
Just go to each and every floor and from ground floor until 100 floor.
First is brute force. So the brute force solution is that I will go to the 0th floor and I will throw it from there. Then I will go from on the first floor and I will throw it from there. Then I will go to the second floor, I will throw it from there. Like that, like that, like that, I will go, and maybe on the 98th floor, when I go to the 98th floor, the egg will break. When I go here, maybe the egg will break. So if the egg is breaking on 98th floor, then I am taking 98 steps. If floor is breaking on 49th floor, then I will take 49 steps. Worst case, I will take 100 steps. Definitely within 100 steps, I will be able to find out. Does everyone agree?
Yeah.
So if it was 100 steps, then it took me, if there are 100 floors, then it took me 100 steps. If there were 500 floors, it would have taken me 500 steps.
500.
If there were 1 million floors, then it would have taken me 1 million steps. So then that is a O of n solution. Does everyone understand why I'm saying O of n?
Yeah.
Correct? 1 floor, 1 step, 10 floors, 10 step, 100 floors, 100 steps.
10 floor
It
and
is growing linearly. I hope all of you understand the word linear.
Yeah.
Linear means how this is growing, same way this is also growing.
पेमेंट लिंक किसमें भेजोगे? व्हाट्सएप में? व्हाट्सएप में? ठीक है.
Okay, so we have found out that we have a brute force solution, which is O of n. Very good. We have some solution. We can say that, sir, it is going to take, worst case, it is going to take n steps, where n is the number of floor. Okay. Now we have to think of optimized solution. Okay. What could be the optimized solution? So I told you that if you are already having a solution which is O of n, okay, if you are already having a solution which is O of n, and I'm asking you to optimize it, obviously in your mind you should think that from O of n I can go to, if I have to optimize it, what are my options? Where can I go? What can I think? From O of n I can go to O of
1 or constant.
either I can go to O of log n or I can go to O of 1. Is this clear or not? I'm not just giving you the solution. I'm telling you a little bit how you have to think also. That not just in this problem, in other problems also, if you already have a O of n solution and still I'm asking you to optimize it, then there is a very good chance that it is going to be O of log n. Now, today you are just starting data structure algorithm, but over a period of time when you solve a lot of problems, whenever you hear O of log n, automatically in your mind a few things will come. That either it will use a binary search or a binary search tree or some kind of a solution where we will cut our sample space in half. There are other applications also, but usually this is it will click in your mind that, okay, log n means I have to think in that way, in somewhere in binary search. Binary search domain I have to go, or binary search tree domain I have to go, or some maybe priority queue or heap kind of a thing I have to think. Whenever you are trying to think in O of log n means you are dividing constantly by 2. Okay, so here if we look at the same problem again, okay, so O of n we have given. Now we are trying to find a better solution. So this will be 0, 1, 2, 3, up till 48, 49, 50, okay, 97, 98, 99, and 100. Okay, so what we will do, it will start from 1 actually. Okay, so what we are saying, we'll go to the 50th floor and we will throw the egg from there. What are the options? Either the egg will break or it will not break. So if it breaks, if the egg is breaking at 50, what does it mean? That the answer is somewhere here. Correct? Answer is somewhere in this domain. This much is waste. Because on 50 only if it is breaking, then 51, 52, 53 till 100, it is obviously going to break. So what is happening? Now my answer is only in this much.
Sir, I think it should be the other way around.
Sorry?
So I think it should be the other way around. If it is breaking at 50, then it might break on 51 also, 52 also. So 1 to
Yeah, so I
49
have to
is
find out the first floor, no, from where it is breaking. If it is breaking at 50, then obviously on all these floors it is going to break. What is there to find out?
no, sir. It should be obvious that it will break on the left side from 1 to 49.
That's what I'm saying.
Okay, got it, sir.
From 50 to 100, it is waste for me. I don't have to check.
Yeah.
I have to check from 1 to 50 or 1 to 49. 50 already I know. So what will I do? Now, same problem. Earlier I was having till 100. Now I'm having till 50. I will repeat the same thing. I will have the 25th step here. I will have the 25th step here. Okay. And I will go to this 25th step and repeat the same process. I will throw the egg from here. Either it will break or it will not break. Suppose it breaks on 25th step. Then what happens? My answer is somewhere here. And this much is waste. Do you guys agree?
Yes.
Yeah.
Okay. So this is a very simple game of, we call it binary search. Okay. You will have to implement this binary search. There is a lead code question also. And binary search is a very, very fundamental thing which you should practice. Binary search can come as a sub problem in a bigger problem. When you are solving a bigger problem, in that you have to implement binary search. So binary search should be so practiced that you should be able to identify and you should be able to write the logic. I'll tell you how to write the logic also. But binary search, be very clear in your mind what binary search is doing. Okay. So what it is doing is it is constantly splitting our search space into half. So when I was having 100 floors, from 100 I came down to 50, from 50 I came down to 25, from 25 I came down to 12. Okay. From 12 I will come down to 6, from 6 I will come down to 3, from 3 I will come down to 1. So how many steps? 1, 2, 3, 4, 5, 6, 7. In 7 steps, 7 or 8 steps, I should be able to find my answer. Are you guys following?
Yes.
From where it is coming, you can say that 2 to the power of 0 is equal to 1, 2 to the power of 1 is equal to 2, 2 to the power of 2 is equal to 4, 2 to the power of 3 is equal to 8, 2 to the power of 4 is equal to 16, 2 to the power of 5 is equal to 32, 2 to the power of 6 is equal to 64, 2 to the power of 7 is equal to 128. So 7 times if you are halving something from 100, you should be able to reach the answer. So that's why we are getting 7 here. It will not even be 8. 8 times you are halving it. Did you guys understand?
Yes.
So what is the time complexity of this? Time complexity of this is, and what we did earlier, this one, this is called as a linear search. So this is O of n, and binary search, this is O of log n. Saif Akhtar is saying that binary search list should be sorted. Yes, correct. So this is also sorted, no? Again, I'm not trying to teach you about binary search right now. I'm just trying to teach you about different time complexities that can exist. Did everyone understand this? Now, if I'm asking you to implement it in Python, how will you do? Can someone help me with binary search in Python?
But how do you determine that it's O of log n? It is like 7 step or 7 or 8 steps, right? Just a gut feeling, or how did we come across it?
How did we get? Okay. Basic maths. If it is 2 steps, 2 floors, then how many steps it will take you? If 2 to the power of 7, if 2 to the power of 7 is 128, okay, then if you take log of both sides, if you take log of 2 to the power of 7 and you take, because this 128 is actually n, you take log of 128, then here you will get what? You will get 7 is equal to log of n. So number of steps is 7, which is log of n. So exponent 2 to the power of something ka reverse is taking log. Do you understand that? Log base 2. This log is, are you hearing this log for the first time?
But what is reason behind using log?
Arey Baba. What do you want to find out? You want to find out that for 100 steps, 100 floors, how many steps? Correct?
There will be 100
So I want to find out
steps.
2 to the power of what is 100? Because every time I'm doubling it, 2 to the power of what should be 100? If I was having 4 steps, 4 floors, then I will say 2 to the power of what is 4? I'll say 2 to the power of x is 2 to the power of 2, so x is equal to 2. तो इसको ही सॉल्व करने का तरीका है ना कि इसको ये तो ऐसे सॉल्व कर दिया, लेकिन इसको सॉल्व करने का तरीका है कि दोनों साइड लॉग ले लो. लॉग ऑफ 2 टू द पावर ऑफ x इज लॉग ऑफ 4. ये लॉगरिथमिक में ये x बाहर आ जाता है, x log of 2 इज इक्वल टू log of 4. ये log 2 बेस 2 ये 1 हो जाएगा, तो x इज इक्वल टू log of 4. log 4 यहाँ पे 4 नंबर ऑफ फ्लोर्स है, यानी वो बिल्डिंग है, तो log n.
Yeah, got it.
The question is how many times you will multiply 2 in order to reach 100. हाँ,
मेरा क्वेश्चन है कि इसको हम लॉग से सॉल्व क्यों कर रहे हैं? मतलब वो तो कॉन्सेप्ट मैथमेटिकली समझ में आएगा, हम लॉग से करेंगे इजी हो जाएगा, लेकिन वो प्रॉब्लम में हम मतलब क्यों यूज कर रहे हैं? मतलब कि क्या प्रॉब्लम, ये अप्लाई कहाँ पे करेंगे ये वाला कॉन्सेप्ट?
मेरे भाई आपको एक लिस्ट दिया हुआ है, उसमें 100 नंबर्स है, 0 से लेके 100 तक है. ठीक है, जब आप पहला स्टेप लोगे तो आप मिडिल वाले नंबर पे पहुंचोगे. 50 है यहाँ पे. ये आपका स्टेप 1 हो गया, हाँ कि ना?
हाँ, स्टेप 1 होगा, राइट.
स्टेप 2 क्या
यस.
होगा? अब आपके पास 0 टू 50, अब आप 25 पे जाओगे, आधे पे.
हाँ.
ये स्टेप 2 हो गया.
हाँ.
अब आप 0 से 25 को आधा करोगे, 12 पे पहुंचोगे, स्टेप 3 हो गया. ऐसे आप करते करते जाओगे, तो आप स्टेप 7 पे जब पहुंचोगे तो गारंटी आपको जो नंबर है वो नंबर आपको मिल जाएगा.
हाँ, राइट.
ये बात आपको समझ में आया कि नहीं?
हाँ,
ऐसा
समझ
क्यों
में
हुआ? ये सात
आया.
में क्यों आया हमको? मुझे 7 ही क्यों आया? क्योंकि 7 बार मैं डबल किसी चीज को किया, 2 को, यानी 2 मल्टीप्लाइड बाय 2 मल्टीप्लाइड बाय 2 मल्टीप्लाइड बाय 2 मल्टीप्लाइड बाय 2 मैं 7 बार किया, तब मुझे जाके 100 आया अप्रोक्सीमेटली.
हाँ, राइट.
एक्स टाइम्स किया मैं 2 को, मुझे ये नहीं मालूम कि एक्स कितने बार करना पड़ेगा.
राइट.
वही मुझे
इनटू
पता
एन
लगाना है
टाइम्स.
कि
ओके.
कितने बार 2 को मल्टीप्लाई करेंगे कि एक्स आ जाए. तो मैं लिखूंगा 2 टू द पावर ऑफ एक्स इज इक्वल टू 100. तो एक्स क्या हुआ? लॉग ऑफ 100.
ओके.
अब आ गया समझ में? कितने बार मैं किसी चीज को डबल करूं, यानी 2 को कितने बार मैं मल्टीप्लाई करूं कि मैं एक नंबर तक पहुंच जाऊं. यहाँ पे 100 है, यहाँ पे n भी हो सकता है, कोई भी नंबर हो सकता है.
तो मतलब ये एक सिंपल फॉर्मूला है कि इस तरीके से reach किया
फॉर्मूला
जाता
आपको
है.
नहीं याद रखना है. फॉर्मूला मैथ का क्वेश्चन नहीं है, मैथ आपको नहीं इसमें याद रखना है. आपको बस ये याद रखना है कि मैं किसी चीज को हाफ करते जा रहे हैं. ठीक है, अगर 1024 होता तो 1024 को आप कितनी बार हाफ कर सकते हो? 512 करेंगे,
10
256 करेंगे, 128 करेंगे, 64 करेंगे, 32 करेंगे, कितनी बार करेंगे जो हम 1 तक पहुंच जाएंगे?
अच्छा, मेरा गोल है 1 तक
1 तक
पहुंचने के
पहुंचना। तो
लिए
ये
तो।
क्या हो रहा है? ये जो 32, 64, 28 कर रही है, क्या है? ये 2 to the power of 5 है, ये 2 to the power of 6 है, 2 to the power of 7 है, ये 2 to the power of 8 है, ये 2 to the power of 9 है, ये 2 to the power of 10 है। यानी 2 to the power of 10 इज इक्वल टू 1024। इसका क्या मतलब हुआ? 2 को मैंने 10 बार मल्टीप्लाई किया तब जाके मुझे 1024 मिल गया।
राइट।
इसको थोड़ा समझ लेना खुद से, लॉजिक मतलब स्कोर, मतलब किसी 2 का किसी चीज को पावर करने का जो रिवर्स ऑपरेशन है वो लॉग होता है। ठीक है, ये डिड एवरीवन अंडरस्टैंड दिस? Binary search is very important. Again, binary search we will discuss little bit later. But I just wanted to show you what O of log n looks like. Guys, are you following?
Yes.
Okay. Let us do one more question. Okay. I'll give you one code. Let me give you one code. I'm saying that. Okay. Suppose I'm saying while I less than 0. Okay. While I less than 0.
एक्चुअली मेरा क्वेश्चन ये था कि ये जो हमने लॉजिक पढ़ा अभी लॉग वाला, तो इसको हम मतलब कि कहीं बाइनरी सर्च में अप्लाई करेंगे क्या ये सेम लॉजिक को?
हाँ, आप ये जो 2 का जो पावर है और लॉग है ना, आप इसमें फंस गए हो मुझे लग रहा है। और बाइनरी सर्च का जो कॉन्सेप्ट है वो आप नहीं समझ रहे हो, मुझे ऐसा लग रहा है। आप बाइनरी सर्च समझे क्या पहले?
बाइनरी सर्च में क्या करते हैं कि एक एलिमेंट है सपोज 1 to 10 तक, तो उसको हम क्या करते हैं, मीट करते हैं।
क्या करते
पहले
हैं?
करते हैं एक की लेते हैं मीट की, उसको हम फिर कंपेयर करते हैं
हाँ
ए इक्वल इक्वल टू मीट।
हाँ।
तो फिर ऐसे करके वो सर्चिंग टेक्नोलॉजी होता है, मतलब कि उसको।
आप बाइनरी सर्च समझे नहीं हो मुझे लगता है। आपको कोड याद है मुझे लग रहा है ऐसे। आप मुझे बाइनरी सर्च समझा सकते हो क्या किया है हमने?
ए ऑफ आई इक्वल इक्वल टू मीट लेते हैं
कोड
इफ
मत बताओ, लॉजिक बताओ।
हाँ लॉजिक मतलब वही है कि जैसे एक एक सपोज हमको मतलब कि एक लिस्ट में मेरे को एलिमेंट सर्च करना है, मतलब कि तो वो एलिमेंट फाइंड आउट करना है। तो उस फाइंड आउट करने के लिए एक बाइनरी सर्च एक मेथड है, तो मुझे
क्या
लेना
मेथड
पड़ेगा
है
कि
वो तो बताओ।
हाँ उसके लिए मुझे सर्च करना पड़ेगा कि मैं एज्यूम करूंगा कि ये जो एलिमेंट है मिड हो सकता है। फिर
ठीक
मैं
है,
मिड से कंपैरिजन करूंगा, यदि वो होगा तो फिर ऐसा करके वो
कैसा
आउटपुट
करके?
आएगा उसका। मतलब इफ इल्स कंडीशन उसको अप्लाई करना पड़ेगा, इफ ए
आप नहीं
ऑफ आई
समझ
इक्वल
आप
इक्वल टू।
बाइनरी सर्च आपको नहीं समझ में आया अभी तक। वेट करो, क्लास के बाद मैं आपको बैठा के समझाता हूँ। थोड़ी देर वेट करो। ठीक है, अभी के लिए भूल जाओ बाइनरी सर्च। ठीक है, बाइनरी सर्च हम लोग अलग से पढ़ने वाले हैं। ठीक है, इसको अगर इंप्लीमेंट, ओके, लेट अस डू वन क्वेश्चन फर्स्ट, देन वी विल टॉक अबाउट इट। ओके, and I'm giving you one piece of code. You have to tell me what will be the time complexity of that. Okay, and I is while I is greater than 0 and I is less than equal to n. Okay, and I'm saying n is equal to n divided by 2. Okay, I is equal to I plus 1. Did you guys understand what is this? Can
Yes.
you Can you tell me what will happen in this one? What should be the time complexity of this?
One to n log n.
Give me the reasoning.
The moment we do n by 2, the while loop will be reduced to reduced to half of the whatever was the original number.
Very good.
And then we are increasing I. That means we are now going to the next like whatever bracket we have chosen of n. Then in the next while loop, again the n is getting divided by 2, which is again like we are reducing the bracket of start and end element. And now we are again incrementing I. So the search will be always between like n by 2. So it is basically like what we were doing in binary search. We were reducing the steps were getting, like it is basically 2 raised to x equals to log n.
Correct. I wrote the code in not a very good way. I wrote, that's what I'm thinking, whether I wrote it correctly or not.
What should be the I value?
I is equal to I plus 1. N is equal to n by 2.
So you said a rule of thumb that if it is getting half in every iteration,
Correct.
then the time complexity is log of n.
Correct. You have understood it correctly. The point is done. But I'm just thinking what I've written here is correct or not. Just give me 1 second.
So I will start increment like I equals to I plus 1. So first time it greater than 0. But next time it will start whatever we have just to be divided. But it will also exclude the first number.
यहाँ पे I नहीं होना चाहिए. I का कोई काम नहीं है यहाँ पे. While n is greater than 1, यहाँ ऐसा होना चाहिए.
n greater than 0.
नहीं. While n is greater than 1. हो गया? इतना ही सही है. ठीक है. इसमें क्या होगा? सपोज n का वैल्यू मैंने कुछ रख दिया यहाँ पे. सपोज 100 रख दिया. इस कोड में क्या होगा? पहला इटरेशन में 100 will become 50. Then 50 will become 25. And 25 will become 12. Like that it will go on halving every time. So this loop will run how many times? If you do here, count, if you keep a track of count, if you make count here, count is equal to 0. And if you do count is equal to count plus 1, then what is the number of count you will get? Can we write this code?
Yes.
चलो कोड लिख के देखते हैं और बाइनरी सर्च का भी कोड इसके बाद लिखते हैं. So we'll call it intro to. By the way, yesterday we did that duplicate problem. Did you guys try it out on lead code? Okay, so I'm saying that while n is greater than 1, n is equal to n by 2. Okay, and I'm saying that count is equal to 0 and n I'm giving some value, maybe 100. Okay, I'm doing count is equal to count plus 1. So I'm printing count. So how many times count should run? It is running 6 times. Why? 2 to the power of 5 is 2 to the power of 5 is 32. 2 to the power of 6 is 64. 2 to the power of 7 becomes 128. That's why. Okay. If I do 128, if I do 128, if I do 512, then it will take 9 steps. So you can write a function for this. If I want to show you the plot of how n is moving, if I write a function def log iter, okay, and I will say n, okay, and I will run it like this, and I will just return count, okay, like this. So if I call log iter for n in range 0 to 1024, okay, if I just say count is equal to print log iter, and I will say n. Count, plus one, count. ये वाला लाइन यहाँ रखना चाहिए, सॉरी. कुछ इन्फिनाइट लूप चला दिया मैंने लगता है. यहाँ पे देखो, हाँ नहीं ठीक है, ये देखो. It is a long thing, but you see, for the first two iteration it is 0, then it is 1 2 times, then it is 2 4 times, then it is 3 8 times. Are you able to understand this? What is happening here? Then 4 is how many times? 16 times. So what is the pattern that is coming? 2
N
4.
is here.
It is coming as 2 4 16 32. So 2 to the power of 0, 2 to the power of 2, 2 to the power of 3, 2 4 8 आएगा. Square 2 to the power of 4, like that 2 to the power of what, how much it is? 2 to the power of 5, like that it is going on. So are you able to see? Means I'm not sure if you are able to understand what happened here. How many counts are happening? That is what it is showing. Are you able to see? And the same logic we will write when we are trying to do binary search. So if I have to write binary search now, same code I will apply here. If I write binary search here, okay, can someone help me write this logic, whatever I showed you for binary search? If I have to implement it, how will I do it using whatever we have learned so far? How will we write binary search if I have to write an algorithm for it? First of all, we can write linear search. So what will we do? What will we do in linear search? Given an array and a number, we need to find if the number exists in the array. Okay. How can we find out? How can we write this logic? Very simple. We'll compare every element to every element. Can someone write this and give me in chat? Array and n. How will we do this? What was linear search, guys? Come on, tell me. For loop inside. Array, you are having an array 10, 15, 20, 30. This is array. And I'm giving you a value called 20. And I'm asking you whether this 20 is existing in this or not. How will you check? Linear search will compare with 10, will compare with 15, will compare with 20, will compare with 30. If we are getting it, we will return, otherwise we'll say false. Yes or no, guys? Come on, tell me. For num in array, if num equal to n, then return
True.
else return not else. We can simply return false here. Is this linear search? Can we try this out? If we are having linear search, then if we are taking an array of 10, 30, 40, and I'm asking you to search 10 here, we are getting true. If I'm asking you to search 100 here, it is giving me false. So have we implemented linear search? What is the complexity for this?
ON.
Complexity is O of n. What is the space complexity? Always write space and time complexity both. What is space complexity? O of 1 only, we are not using any extra space here. Okay, now same logic we have to write in linear, we have to write in binary search. We will be given array, we will have n, and we have to implement binary search. So what should be the approach? What we will do? Let us revisit what we have done. Okay, so suppose if I am having 15, 20, 30, 60, 80, what I have to do? Saif is saying first we have to sort the array, correct? We have to, step 1 is we have to sort the array. Okay, usually if you are working with binary search, you will see that the question situation is such that we will always have sorted array. If you don't have sorted array, you have to sort the array. Okay, fine. After that, what will be step 2? If you see the description that I gave you, the description was that we are having 1 till 100. Okay, we are having from 1 till 100. And after the first step, we got our sample space into half. So if we were having 100 elements in the first step, in the next step, we are having only 50 elements. It can be 1 to 50 or it can be 51 to 100, depending on what happened at the middle index. But either it is possible that I can have either 1 to 50 or I will have 51 to 100. If I'm working with 1 to 50, my next step can be 1 to 25 or it can be 26 to 50. Whatever happens, our span is getting reduced to half. Okay, so we have to keep track of our span. So span is defined how? It is defined by where you are starting and where you are ending. This binary search is a very, very good example of many things. Binary search also, logarithmic time also, and your pointer manipulation also. So pointer also you will get a good idea. So what we will do here, is we will take the numbers. Say for example, if we are doing 1, 2, 3, like that 50, like that 98, 99, and 100. Okay, we will take one pointer here and we will call this left, and we will say this is our right. Is everyone with me till here? What is this left and right telling me? That my data is between left and right. So my left is at 0 and my right is at 100. 100 or 99, depending on how you are indexing it. Guys, following, yes or no? Please tell me in the chat. There's a lot of silence. What is the next step? Find midpoint. How will we find midpoint? I'm going like very, very slow, step by step. Okay, because first time you are learning how to write code from scratch in DSA. But once we do this, then next onwards and after that, we will go a little bit fast. Okay, we'll do midpoint. How will we find midpoint from here? What is the midpoint? Left plus right by 2, correct? Left plus right by 2. That will be our midpoint. Okay. After that, what we will do? After that, once we have found the midpoint, then what we will do? We will compare target with midpoint. Once we are comparing it, what are the possibilities? The midpoint can be greater than target, or the midpoint can be smaller than target, or maybe equal to target, so greater than equal to, let me say, or it can be equal, so let me keep equal separately. Are you guys following?
Yes.
Can be greater than target, less than target, or midpoint can be equal to target. Okay, if it is equal to target, then our job is done. Then
You
we
can
will
stop it.
then we will terminate. We have found out. If it is greater than target, then what we will do? If our midpoint is more than target, then what we will do?
We'll go in second half. Right side one will go.
Right side or left side? If mid is only greater, then everything on the right hand side of the mid will be greater only. So you have to go to left. Are you guys following? You have to go left. How will you go left? So if mid is greater than target, then what we have to do? We have to go left, discard right. So when I say go left, then what does it mean? That initially we were like this: 0, 1, 2 till 50 till 100. Okay, and here was our left pointer, and here was our right pointer. If we have to go left, then what does it mean? It means that I will take this right pointer and I will move here. And this area, this much, becomes my new question. This much is discarded. Is it clear? And if mid is less than target, if mid is less than target, then what we will do? We will go right and we will discard left. So here what we will do? Here we will say that right pointer, in this case, the right pointer will become mid minus 1. Right pointer will not be mid because mid we have already checked. So we'll go one left towards mid, one leftward of mid. If mid is less than target, then we will go right. So what we will do? Guys, are you following? Or should I repeat from beginning? 0, 1, 2, up till 50, up till 98, 99, 100. Okay. In the beginning, you were having left here and you are having right here. Now, when you went to mid, okay, this mid is less. So then what you have to do? You have to move towards right. So I will take this left pointer and I will put it after mid. I will put it here. Okay. So in this case, my left will be mid plus 1. Did you guys understand? When we have to stop this condition, left is equal to mid plus 1, look in the right half. Left is equal to mid plus 1, look in the right half. Right is equal to mid minus 1, look in the left half. Tyler, what you are writing is correct. So majority of the logic you have understood. Now, how do we put it in form of a code? what we will say? First, we will say that our low will be equal to 0, or let me say usually when we do binary search, you will say low and high, but I'm saying left and right, that is fine. So I'll say left is equal to 0, right is equal to length of array minus 1. I'm writing line by line. Is this okay? Okay, then we have to run a while loop. If you remember, when I was teaching you about while loop, I told you that when we do while loop, we have to think about terminating condition, where this condition is going to end. So when we are doing this drama of moving the left pointer, right pointer, we are shrinking. When are we going to stop? When are we going to stop? Let us take a smaller example. Let us say that it is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Suppose this is array. And suppose the target is 7. I want to find where 7 is in this list. Okay. So let us do a dry run. We'll do a dry run. This is my left pointer and this is my right pointer. Okay. And where is my mid? This is my mid. Suppose. Okay. 6 is my mid. 6 is greater than target or 6 is less than target? 6 is greater than target. If it is greater than target, then what we are doing? We are moving 6 is less than target. So if mid is less than target, then we are moving left pointer to mid plus 1, which means we will move this left pointer to mid plus 1. We'll bring it here. Okay. Again, we will calculate the midpoint. Where will be the midpoint? Suppose it is at 9. Okay. 9 is less than target or more than target? 9 is more than target. So what we will do, we will move the right pointer. Okay. So we'll move the right pointer. What I'm trying to show you here is where we are going to end this. How will we know the process has ended? Okay. So left has come here. Now between 7 and 8, where is the midpoint? Suppose it is at 8, midpoint. It depends on how you're defining the midpoint. It can be left or right, because between 7 and 8, when you do division by 2, you will get it that way. So suppose 8 is the midpoint. Again, 8 is greater than our target. So what we will do? We will move our right pointer again, mid minus 1. Mid minus 1 is at this place. So our left and right pointer has come in the same location. Okay. So when this is the case, then we will stop our iteration. So while left is less than equal to right, Tyler, what you are saying, that is correct. Okay. So can we write complete the logic now? Guys, is everyone following? Is there anyone who is not understanding? Please tell me now itself. Okay. So what we'll say, while left is less than equal to right. Okay. What we'll do, we'll calculate mid. So we'll say mid is equal to left plus right by mid is equal to left plus right by 2. We'll write it like this. We'll write it. This is float division, all of you know. Now there are 3 cases. What is the first case? If array of mid equal to target, then we will return mid, no problem. Second case is that the mid is less than target. Okay. And else array mid is greater than target. These are the three possibilities. Either it will be equal, or it will be less than, or it will be greater than. So if it is less than target, then what we are saying? We're saying that left is equal to mid plus 1. And if it is less than target, then we'll say right is equal to mid minus 1. After doing all this, if we are not able to find anything, then that means that number does not exist. We'll say we will return minus 1. This is the code for binary search. This we should have it on our fingertips. And this, what does return minus 1 signify? Minus 1 signifies that we were not able to find the target. We could not find the target. We could not, that target does not exist. Okay. So here we are returning false, right? So these two questions I've written in a different way. Here you can write the problem statement. Given an array number, we need to find if the number exists in an array or not. So here we are returning Boolean. We are returning Boolean. You can frame the same question in a different way also. Let me delete it from here. Let me take the same question here. We can say given an array number, we need to find if a number exists in an array. We need to return the index of the number if it exists in the array. If not, then return minus 1. Okay, so linear search का लॉजिक थोड़ा सा चेंज हो जाएगा, इसको आप लिख लेना. कैसे चेंज होगा, क्या करना पड़ेगा वहां पे? What we will have to do in linear search, you will have to run iteration on the index. When the index is correct, that time you have to return it. Okay, you can do that. So binary search can be right now. Okay, what will I say? I will say left is equal to 0 and right is equal to length of array minus 1. Is this correct? We'll say while left is less than equal to right, we will find the midpoint. Okay, we'll find the midpoint. How will we find the midpoint? We'll say midpoint is equal to left plus right, left plus right divided by float division by 2. Okay, and after that there are three conditions. Target is equal to mid. In that case, if we say that if array of mid target is equal, if, then we will return mid. Okay, elif. Okay, what is the second condition? Target is greater than mid. If target is greater than mid, then what do we do? Target is greater than mid. Then we will search in the second half. So what we will do? We will say left is equal to mid plus 1. Okay. Else we'll say right is equal to mid minus 1. At some point, the target will become equal to array mid. When that is the case, then we will return the mid. When if or after doing all of that, if we are not able to return, then we will return minus 1.
I think you need to put in the brackets as a target, not
sorry. Here we will put target. Okay. Is everything correct now? Target, if array mid target, we'll say target is greater than. Guys, all of you are following till here. Can we try this binary search? Okay, so let us try this binary search. Okay, and we will try it, and then we'll write it in lead code also. I think if you go to lead code, you can see there's a question here. So we'll try to write that. Okay, so binary search, we'll say maybe 10, 20, 30, 40, and 50, and we'll say search for 40. Okay, so what should the answer be? Answer should be 3, 0, 1, 2, 3. So 40 is at index 3, it is giving us, correct? And if we say 400, then it should give us -1 because -1 does not exist. Okay, can we take this code and can we put it here? Binary search question. Okay, so in the question, we'll read the question also first. Question says, given an array of integers nums which is sorted in ascending order. See, question is that it is sorted in ascending order. Okay, here we should have sorted also. I did not do that here. The first step should be sorting. Okay. If array is not sorted, then sort the array. Okay, here we'll say that array is sorted given an sorted array. If it is not sorted, then you have to sort it. Just keep that in mind. Okay, so given an array of integer nums, are you able to see the screen? Given an array of integer nums which is sorted in ascending order and target integer target, write a function to search target in nums. If target exists, then return its index, otherwise return -1. You must write an algorithm with O of n runtime complexity. O of runtime means O of n means O of log n means binary search. Okay, so you can see here there are some examples given. Nums is equal to -1, 0, 3, 5, 9, 12. Target is equal to 9. Output 4. 9 is existing and therefore index is 4. So it is returning. And here target is 2. 2 is not there in the list. So output is -1.
Can you explain this question at least?
This question. यही क्वेश्चन तो सॉल्व कर रहे थे अभी तक.
What?
ये जो यहाँ पे जो मैंने क्वेश्चन लिखा है और जो सॉल्व किया है वो सेम क्वेश्चन ही तो है.
नहीं, क्वेश्चन का मतलब थोड़ा समझ में नहीं आया.
गाइस थोड़ा ध्यान दीजिए यार. मतलब मैं आप आधा घंटा समझाया उसके बाद आप पूछ रहे हो कि क्वेश्चन ही नहीं आया मुझे.
नहीं, वो समझ में आया. ये वाला
वही क्वेश्चन है भाई. एक क्या बोल रहा है? गिवन एन अरे ऑफ इंटीजर नम्स. एक मुझे नम्स दिया है, उसमें अरे ऑफ इंटीजर्स है 10, 20, 30, 40. array of integer which is sorted in ascending order and an integer target. एक टारगेट दिया है मुझे. टारगेट सपोज है 30. तो मुझे ये पता लगाना है कि इस नम्स एरे में जो 30 है वो कहां पे है. अगर है तो उसका इंडेक्स दे दो, नहीं है तो -1 रिटर्न कर दो. यही है क्वेश्चन. तो यही तो हमने किया यहाँ पे.
हाँ, समझ में आ गया.
थोड़ा ध्यान दीजिए. ठीक है, तो ये हमने दिस इज द कोड दैट वी हैव रिटन, but slight modification we'll have to make because in the question the variables are different. Just give me 1 second. I have to log in actually. It's not. Guys, can you see the screen? Okay, so we log in. It is here instead of nums, it is array. So we will just make it nums here and we'll make it nums here. And I think here it will be nums and target is there. Fine. So can we run it and see? Let us run it and see if it works. So you can see that for our simple test case, 2 test cases, it is working fine. Okay. So once we have done that and it is working fine, then we can submit the code also. So if we submit the code, you can see here that it is saying beats 100%, which means our whatever code we have written, it is very good. Now this 100% sometimes it will change. This is a very simple question, so you are getting, but sometimes you will not get 100%. But this is fine. Now here there's the option of analyzing complexity. So lead code gives you one option also. You can click on analyze complexity and say it is saying O of log n. Now, if you are a free user, then you cannot use this many times. Only I think one time they will allow you to use it in one day. But here I'm showing you this is O of log n. Did you guys understand?
Yes.
Okay. Can you write the same logic using linear search? If you have to write using linear search, how we would have written? Just for practice. This time complexity is O of n, guys. We spent a lot of time on this, okay? O of log n and space complexity is O of 1. Okay. Linear search, how will write? Can someone help me in chat, please? In lead code, return type is the function. Is the return type the function assumed? Say what you're saying, I'm not able to understand. We can simply say that for index num in enumerate array, okay, if num is equal to n, then return index, else return -1. Okay, so this is also logic, but this is O of n, but we can try it out in binary search. Later we can see whether it works or not. It may work, may not work, I'm not sure. Because in the question it is written that we have to do it in O of log n, but still we can try. So here we will be giving nums. And let us see, it works. N is not defined, target. Okay, so this is also working. If we submit, I don't know if it will work or not. Code is correct, but it is working fine. It is working. Analyze complexity we cannot do because I'm using free version. But this is not an acceptable solution. It is working on lead code, but you have to write it in O of log n as per the question. So our binary search solution was correct. Did all of you understand, guys?
Yes.
Did you understand two-pointer approach? Two things are very important in this. One is understanding of how complexity is log n. It will be very helpful for you in later also when you're learning other data structures. And second is understanding of pointers, how we took left pointer, right pointer, mid pointer, compared, and we moved the left and right pointer. That pointer approach is very, very important. It is you are going to use it all the time. In linked list also you will use it, and in queue and in stack and everywhere you are going to use this two-pointer approach. In array you are going to use it, string you are going to use it. Always we will use that.
Hello. The other option that you have used here, the other code that you have used here, enumerate one, it will also take the login time, no?
No, this is linear search only, no?
Sorry, O of n time, sorry.
This is linear search.
Yeah, but it is working here.
It is
in the
working, but it is not O of log n. Question में लिखा हुआ है O of log n. It is O of n, but it is getting accepted on lead code. That is different thing.
हाँ, वही मैं कह रहा था कि O of n पे ये चल रहा होगा.
O of n पे चल रहा है.
इटरेट कर रहा है ना सब.
हाँ, एक कुछ चेक कर रहा है. तो ये लीनियर और लॉगरिथमिक का जो कंपैरिजन है ना, दिमाग में बैठना बहुत इंपॉर्टेंट है. कि एक में हम सबको चेक कर रहे हैं और एक में हम हाफ तोड़ते जा रहे हैं. लेकिन एक चीज ध्यान में रखना है कि सॉर्टेड होना चाहिए एरे.
Got it.
एरे सॉर्टेड होना चाहिए. अगर कभी भी आपको सॉर्टेड एरे मिले और उसमें कुछ सर्च करना हो, तो ट्राई करना उसमें बाइनरी सर्च फिट होता है कि नहीं. कभी कभी वो ट्रिकी रहेगा, लेकिन ट्राई करना कि उसमें बाइनरी सर्च फिट होता है कि नहीं. बाइनरी सर्च उसमें फिट होता है तो वो ऑफ लॉगिन हो जाएगा. Okay, this was two-pointer approach. Okay, so when we talk about arrays, sorry, array we were not discussing, we were discussing time complexity. We'll start our discussion about arrays now. Okay, already we got some practice about arrays, but till now what we have discussed, okay, we have discussed what are data structures, okay, and we took example of array and linked list. Then we talked about algorithms, and then we talked about time complexity. Okay, and in time complexity we understood what is O of 1, what is O of n, what is O of log n, and what is O of n squared. This much we have learned. Okay, till now we have covered this much. So in this much, does anyone have any questions? So this is your introduction. I have completed the introduction to DSA using a lot of examples and covering a lot of other things also. अभी तक आप लोग को कैसा लग रहा है? समझ में आ रहा है, नहीं समझ में आ रहा है, अच्छा लग रहा है, बुरा लग रहा है, गुस्सा आ रहा है, क्या लग रहा है?
अच्छा है. We're deep diving into our logic.
Sorry?
We are trying to deep dive into our logic. So which is correct, is wrong.
I'm not able to hear you. Deep dive into what?
The logic, what we are writing it.
समझ में आ रहा है? Are you finding it
Yes, yes.
understandable? ठीक है. बाइनरी सर्च, हाँ, ब्रेकिंग कंडीशन थोड़ा सोचना पड़ेगा. ब्रेकिंग कंडीशन कैसे सोचना पड़ेगा ना, कैसे पता चलेगा? ब्रेकिंग कंडीशन में आप हमेशा कंफ्यूज हो गए, मैं भी कंफ्यूज होता हूँ. ब्रेकिंग कंडीशन में ही सारा ट्रिक होता है. पता है, जब आप कोड लिखोगे तो जो मिस्टेक्स होते हैं वो हमेशा या तो ब्रेकिंग कंडीशन में होगी, एज केसेस में होगी, या कोई ऐसा केस जो आपने इमेजिन आपने नहीं किया, बाउंड्री केसेस पे होगी. ठीक है, तो जब भी आप कोड लिखते हो, whenever you are writing the code, you have to always think about, if you are writing loops, what will be the breaking condition, where the pointers will be initialized. Here when we wrote the code, for binary search, कहाँ गया? When we wrote the code, it was mid -1 and mid +1. इस चीज का आपको ध्यान रखना है. ठीक है, so how you will get it? It's not just writing code, because you will not, obviously nobody will ask you to write a binary search, but how will we arrive at that is by doing dry run. So if you remember in the last class, when I was asking you the question of reversing the string, I told you a few things. One was that you understand the question. Okay, I don't know if right now you will appreciate this thing, but you have to understand the question. You have to, and this is for all interviews point of view, you have to ask clarifying questions. Okay, then you have to propose brute force. Okay, and then you have to talk about time complexity and space complexity of brute force. Then you have to propose optimization. Then for optimization, you have to do time complexity and space complexity. For optimization, then you have to do a dry run on 2 to 3 examples. Okay, once you have done the dry run, then you have to discuss about boundary conditions. And assumptions. And then you have to write the code. And once you have written the code, then again you have to do the dry run. So these are all the steps that you have to follow. And while you are doing all of this, you have to make sure that you are always communicating. This is very, very important. It is possible that you can get stuck somewhere. Maybe you are stuck here, or you are making any mistake here, or you are making some mistake here. You are making a mistake here. It is possible. All of us are humans. We cannot do all of this perfectly. But you have to constantly keep communicating. And the person on the other side, he is going to help you. But you have to create an environment where he is able to help you. If you are only thinking and not saying anything, and you are just writing and there is silence, then you are gone. Okay. So whenever we are solving the question, even when I am solving the question, I'm going through all these steps. I did not do this step, I did not do this step, but otherwise I'm doing the brute force optimization. Then we are doing dry run, how pointers are moving. Only when you do that pointer moving, then only you will understand, okay, what is the breaking condition. That's why for the breaking condition, we spent so much time on this example. If you now watch the video, if you are watching the recording, then you will understand that after writing all the code, then why did I do this part? Everyone with me? Generally, how much time given for this? What do you mean, Ashish? How much time given? 40 minutes. 40 minutes with 2 questions. So you can, if it is an easy question, again, it's depending on different places. But normally you can have like 40 to 45 minutes. You can either have one question. So if that is one question, then it will be slightly hard. Or it can be 2 questions if it is medium. Or it can be one question, medium, plus 2 follow-ups. So 45 minutes, you can say that 20 minutes discussion and maybe 10 minutes code and 10 minutes of again discussion about code or follow-up. Again, it is not hard and fast, but normally 45 minutes you will not end up writing code. You will write code only for 10 to 15 minutes. Main thing is this. Writing code is the last thing. Main thing is this. Follow-up means whatever you have written in that they will ask you. That if this happens, then what will you do? If that happens, then what will you do? If you have not mentioned time complexity, space complexity, then they will ask what is the time complexity, space complexity. If I change this, then what will happen? If I change that, then what will happen? All those things. Can we take a break and then we'll start again? We'll start with our arrays. But is introduction part clear to everyone? Have you understood what is data structures, algorithms, time complexity? Those who have understood, please write yes. Those who have not understood, write no. Okay. If that is the case, then it is 5:30. We will take a break till 5:45. Okay. 5:45 के बाद मिलते हैं. Okay. 5:45 पे मिलते हैं. Okay. Okay, guys, we'll start now in 1 minute. If you are here and there, please come back. Guys, can we start? Please tell me in the chat. Is everyone here? Okay. We'll continue our discussion and we'll talk a little bit about arrays. Okay. So array is the most fundamental data structure. Whenever you are trying to learn data structures, the first thing that you are going to learn is array. Okay. Understanding of array is very important, not just because array is an important data structure, but because other data structures also are somewhere or the other built on top of array. So even in the future, when we are learning other data structures like linked list, queue, or hash maps, every time we will constantly keep referring back to arrays. Okay, so array we have to understand properly, and in terms of problem solving also it is very important. In terms of logic building also it is very important. So when we are learning about array, especially from DSA perspective or a lead code solving style perspective, there are two aspects to learning arrays. One is the academic understanding of arrays, and second is the problem solving patterns related to arrays. So we are going to do both, but we will focus more on the problem solving aspect. Okay, so first we'll just understand what is array, what is the low level array, what is array in Python, and then we will learn about what are the different patterns, and for each pattern we will do 1 or 2 questions, we'll do practice, and 1 or 2 questions I will give you as assignments which you can solve. So per pattern, if you solve 4 or 5 questions, then you will be in a confident position. Okay, chalo. So what is array? So before learning about array a little bit, I want to talk about memory. Memory versus storage. So you must have heard about memory, and you might also know about storage. So what is the difference between memory and storage? Memory is your temporary location where all your data is stored, which is being used by any program. Okay, so it is temporary and it is volatile. Volatile means if you switch off your computer, everything that is there in your memory is gone. So what is the use of this memory? The use of this memory is that it is very fast to access. Okay, compared to storage. So what do I mean by storage? Storage is permanent, okay, but it is slow to access compared to memory. And it is non-volatile. Okay, so whenever we are working with memory, okay, whenever we are working with any of our programs or we are talking about efficiency and all, we are talking about memory. Okay, this is the memory is what we are talking about most of the time. Okay, so we'll learn about how this memory is actually structured and whatever code we are writing, how it is interacting with the memory. Okay, so in memory, the most primitive way, like I started our discussion when I said that we want to solve real world problems and we want data to solve those problems. That data is stored in the memory. Okay, how is that data stored? It is stored in the form of bits. So this is the most fundamental unit. Okay, and normally we talk in terms of bytes. So we say 8 bits. We say it is 1 byte. So whenever we are storing our data, we are storing it in the form of zeros and ones. You know that binary, whatever data you have, whether it is character, whether it is number, whether it is float, boolean, whatever you're storing, it is in the form of 0, 1, 0, 1, 0, 0. Okay. So each of these 0 or 1 that is being represented by 1 bit. Okay. Again, we are not going to bother too much about what is this bit and byte. Just for your understanding, I'm explaining it a little bit. Okay. So these memory locations which are there in our CPU. Okay. These are some memory locations in our CPU. Suppose this is our memory. Okay. So there are a lot of memory cells. I'm just making it a grid. Actually, it is just for visualization. Okay. So each of these grid, this is one memory cell. Okay. One memory cell you can assume to be whatever. Maybe you can say it is 1 bit, or you can say it is 4 bits. You can say it is 8 bits, whatever you want to imagine, you can imagine. Okay. So these are different memory locations, and each memory location will actually have an address. We'll call it memory address. Okay. So when you say in Python, when you say x is equal to 5, guys, is everyone following what I'm saying? Chat mein likho yaar, yes or no? Okay. When you're saying x is equal to 5, what actually is happening in Python? You are saying that x is equal to int 5. Okay. So what is this doing? This is creating an instance. It is creating an instance of integer class, which is 5. And it is storing it in some memory location. Maybe it is stored here. Maybe it is being stored here as 5. Okay. And then we have this x. So we call this x is an identifier. Okay. So this x actually is pointing to the memory location. Maybe इस memory location का जो address है वो है 2008. तो ये जो x है, this x is pointing to this memory location. Is it clear? Now this 5 can take some space. So normally it will take 32 bits, or it can take 64 bits depending on your CPU configuration. Normally it is 32 bits. If you're saying that y is equal to y is equal to 10.8, okay, so this y can take up to 64 bits. Okay, 64 bits, or we say it is 8 bytes. 32 bits, or we can say 4 bytes. Okay, so this 10.8 or 5, or when you are saying name is equal to Tyler. So this Tyler is also stored in the memory, and this name is actually pointing to the memory location where that thing is stored. Now, because there is a memory address, let me take this example, simpler example. Okay. If I'm taking a memory address like this, I am saying there are different memory cells here. Okay, and each memory cell will have some address. So maybe this is 2000, this is 2004, this is 2008, this is 2012, this is 2016, this is 2020. So I'm assuming that this is 1 byte or 4 bits, which means 4 bits means इसमें ऐसे 4 bits बने हुए हैं, ठीक है, ऐसे करके उस 4 को मैं नहीं काउंट कर रहा हूँ, आई एम काउंटिंग दिस एज 1 unit. Okay, so if you have to store something, you can store here. Now, good thing about memory is that if you have the way the CPU works is that if you have the address, suppose this is 2008 or 2016, if you have the address, okay, any element, any memory location can be accessed in constant time. Given the address. Any random memory location can be accessed in constant time. So that's why this memory is also called as random access memory. You must have heard it in your school. or this is also called as RAM. All if you're following. So if you know the memory location, if you know the memory address, then you are able to access that. And that is also one primitive step. If you remember yesterday when I was talking about time complexity, I was telling you that we count the number of operations and for counting the number of operations, we need to understand what is one primitive step. So this is also one primitive step. If you know the memory location, if I tell the CPU that go and check what is there in 2008 memory location, it will go and immediately check. If I will ask it to check 3000 memory location, it will check. If I will ask it to check 10,000 memory location, it will check immediately within instance. Okay, so that is why accessing data from memory is very, very fast, because it is indexed. Or not index, sorry, there's a memory location which is allowing it to access whatever data is there in that memory location. Correct? All of you are with me till here? So when I'm saying, if I create this memory location like this, okay, like this, like this, like this, and if I say x is equal to 5, then 5 will go and it will occupy some memory location, and this x actually is pointing to this memory location. Similarly, if you say y is equal to x, then y is also pointing to this memory location. Okay, if you say z is equal to x, then z will also point to this memory location. Okay, so data being stored and identifiers pointing to a memory location. This part is clear to everyone? Okay, now if I want to store some data, if I want to store some more data, yesterday I was giving you the example that if you want to store marks, okay, so you can say marks 1 is equal to 10, marks 2 is equal to 20, like that I can store marks of 10 students. But I don't want to store it like this, because it becomes difficult if you want to sort it, if you want to access it. It is not very convenient if we have different number of variables. And here you are having 10. If you want to insert someone in between, if you want to delete someone from between, it becomes problematic. So what we do is we take a part of memory. Suppose we want to store 10 marks 1 to marks 10. Okay. So what we do is ये पूरा जो memory है, memory location में, okay, suppose this is a big memory block. There are more memory blocks. Okay, a lot of memory blocks. Okay, we will rent one area and we will say that this is where we will store. So we'll say that we want to store 10 marks. So I'll say 1, 2, 3, 4, 5, 6, 7, 8. From here we will store. Okay, so we'll rent this much space. We'll say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How much ever it is, just count it. Okay, this much memory location we will store. Okay, so this is what we have rented. And all the memory location, if we take it out, it will look like this. One, two, three, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so this is a contiguous block of memory that I have taken. Okay, or I gave you the example of some people going and watching movie. So there are 10 people, they want to go and watch the movie and they want to sit together. So they have to look for a consecutive block in the theater, and they will reserve that consecutive block so that all of them can go and sit there. Guys, all of you are following? कोई तो कुछ तो बोलो यार, इतना सन्नाटा क्यों है?
Yes, sir.
If you guys don't interact, no, then I feel very lost. If you're not saying, at least keep saying something in the chat. If you are bored, you can crack some jokes. I don't mind, but keep talking. Okay. Otherwise, I feel I am talking alone. It's like me recording a YouTube video. I don't want like that. Okay. You guys, please keep at least saying yes, something you say. Okay. So this is one memory location we are taking. So each memory location, if we keep track of the starting memory point. So if suppose this memory location is 50 and this becomes 54, this becomes 58, 62, 66, 70, 74, 78, and 82 and 86. Okay, so these are the memory locations that I've taken from 50 to 86, and here I will store my marks. 10, 12, 18, 42, 68, 99, 50, 42, 33, and 21. Okay, so these are the marks that I'm storing. So this contiguous block of memory, okay, this I will call it as 1 marks. So this arrangement, we will say this is one array. So what are the things in array? What are the points in array? Oh, why is my system hanging? What is array then? If I have to give you a high level definition, and what is the array? Can I say that it is a collection of elements, okay, of same data type? Okay, or we can say this is homogeneous. Okay, stored in contiguous memory blocks or memory cells. Okay, each cell having same storage, okay, and accessed using index. If these are the criteria, then we will say that it is an array. I don't want to give you a bookish definition, but I hope you have understood. What is an array? We will take a contiguous memory block, okay, and we will store some data here. So 8, 16, 20, 15, and 24. So here data type is similar. This is also integer, this is integer, this is integer, this is integer, this is also integer. Okay, and this is contiguous memory block. So if this is 50, this is 54, this is 58, this is 62, this is 66, and this is my, you can say, marks. Definition of array is clear to everyone?
Yes, sir.
Okay, now what can we do with this array? We have already discussed. We can access elements in O of 1 constant time, because I told you in memory, if you know the location, if you know the memory location of any address, you are easily able to access that element. So when we create an array, we keep track of what is the starting index. So here it is 50. If we know 50, we can access 8. And if I'm saying what is the element after 8, you'll say, okay, 50. And because it is integer, so it is 4 bytes. I know that it is 4 bytes. All of them are 4 bytes. So I'll just take 4 steps and I'll go to 54 and I'll see I'll find 16. I'll say, okay, what is the element after that? Next to next. So next to next means 4 plus 4, 8. So 54 plus 8 I will reach 62. I will be able to access this number, what is 15. Okay, so I'm able to access any element in constant time. This part is clear. We have discussed this yesterday also. All of you are with me till here? Why this white color is not coming? Okay, we are able to access the elements. What else? We can insert or delete elements. We can search for elements. Okay, these are the things that we have already seen. Now, what else? Let us talk about some type of arrays or some concepts adjacent to arrays, which is static array and dynamic array. Okay, so now the definition that I gave you of array is that we are having collection of similar items suppose it is 10, 15, 20 and 40. So what I said, that I will take contiguous block of memory. So I want to store 4 elements. So I will take 1, 2, 3 and 4, and very nicely I will store here 10, 15, 20 and 40. Okay, and this is a memory block. Suppose this is 2000. Suppose this is 2000, this is 2004, this is 2008 and this is 2012. इसके पहले भी कुछ मेमोरी है, इसके पहले भी कुछ मेमोरी है, और इसके बाद में भी कुछ मेमोरी है. It is possible that those memories are open or those memories are already occupied with something. So here maybe I'm storing some other value. Maybe here there is 14,000, 18,000, some other list is stored here, 25,000. And here also there is some other value, which is maybe 0.2, 0.8, 0.2 तो नहीं हो सकता because that will be different. But I can say 400, 800 and 600. Okay, and these are memory locations. They are for some other data, but our data is stored from here till here. All of you are following till here, guys? Now, what is the problem? If you say that, boss, please append something. Please append something here. I want to append a new value 50. I want to put it here. Is it possible to do here in this arrangement? You will say that yes, I can insert it here, but here there is already one element. There is no space. So this type of array is called as a static array. Fixed size. Would you want to work with static arrays? Or if you're working in C language, you will see whenever you are creating an array, you will always tell what is the data type and you will tell how many elements you want to store. Not like Python. In Python, we can create a list and then we can say append. We can keep increasing or decreasing. But the basic array, the low-level array, when we are talking about a low-level array, then the size is fixed. If you want to store 10 elements, then you will store 10 elements. There is no scope for adding 11th or 12th element. Okay. The other part of this is what we call as a dynamic array. So in dynamic array, what happens? Suppose you want to store the marks, and marks is suppose 10, 20, 30 and 40. Okay. So what we will do is that if we have to store 4 elements, suppose we are taking a block of 4. 1, 2, 3, 4. Okay, so we are storing 10, 20, 30 and 40. Okay, and this is one memory location. And similarly, there are a lot of memory locations. Today my drawing is very, very bad. I want you to imagine that this is a big memory block. Okay, and in that memory block, there are a lot of memory spaces. Okay, so this is the memory space that has been given. So now what will happen if I want to add something? If I want to add something here, suppose I want to add 50 here. Okay, and this 50 also has to be contiguous. Then what I will do, when I have to add, I will take another memory location. I will leave this memory location. I will look for a better memory location, which will have 5 elements. So I'll take, maybe this is empty here. 1, 2, 3, 4, 5. So I'll take this memory location here. and I will move everyone there. So I will say 10, boss, 10 you come here, 20 you come here, 30 you come here, 40 you come here, and 50 you can come here. So if we do this, then what happens when we append? Every time we append, it becomes O of n operation, because if you have to add one element, then all the remaining elements you have to move, you have to shift. Are you guys following? Yes or no? Okay. So what dynamic array will do, what dynamic array does, dynamic array is working on the same concept of resizing, but it will do one more thing. What it does is that when you are saying that I want to store marks of 10, 20, 30, and 40, so you have to store 4 elements. So it will by default take more than 4 space, so that later if you want to add something, there is some buffer. It's like in childhood, our mothers used to, when we used to buy school shoes, we will buy one size extra. If I'm wearing size 7, I will buy size 8, so that it will fit me, and next year also when I'm growing, the shoe will fit me. So we are taking some buffer, so that immediately we don't have to buy new shoes. Clothes also will buy a little bit higher size clothes. Correct, no? Same concept. What Python will say that, okay, you are asking me to store 4 elements. Fine. I will take 8 blocks for you. Store 4. I'm taking 8. Tomorrow, if you want to add something, then you will be able to add. So what Python will do, Python will block this much memory. 1, 2, 3, 4, 5, 6, 7, like this. And we will store here 10, 20, 30, and 40. And this much will be available for us as buffer. So tomorrow, if you are saying add 50, we can say, okay, we will add 50. And then you will say, okay, add 60 also. So we'll add 60 also. Then you'll say add 70 also. We'll say, okay, fine, add 70 also. We'll add 80 also. Fine, we'll add 80 also. Now, whatever buffer we have taken, that is also full. Whatever buffer we have taken, that is also full. But what was the benefit of the buffer? Benefit of the buffer was that these many elements, when we were appending, it happened in O of 1. All of you are following? Once the buffer is also filled, once the buffer is also filled, then what Python has to do? Python has to resize. So if the size has become 8, next time Python will say that, okay, you want to store 8th. When you are trying to put 9th element in this, we don't have space. So Python will again do the same work which we did here. It will go to a different memory location, and it will find some different memory block which can be accommodating of the 9 elements. So instead of 8, it will block for 16. So it will take 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. It will take 16 blocks. Only 8 are filled, but double we will take, and again we will keep in buffer. Okay. So I'm simplifying it. It is not actually always double. There is some calculation for every language, but roughly it will be double. You can say roughly it is double. So again, we will copy all the elements. 10 will come here, 20 will come here, 30 will come here, 40 will come here, 50 will come here, 60 will come here, 70 will come here, 80 will come here. And after that, whatever element you are asking me to put here, 90 will come. And this much will be there for buffer. Now, after that, again, if you are asking me to add something, I can add it. But when we were doing resizing, this resizing is costing me O of n. Are you guys following? But once I have resized, then for subsequent appends, it will cost me O of 1. When the buffer is completed, then again we have to pay O of n. Is everyone with me? So this what we are saying, this only we are saying that when we are doing insert, we say it is O of 1, but we say this is O of 1 amortized. Amortized का मतलब on average. Average का मतलब it means usually it is O of 1. Occasionally, when we have to resize, it is O of n. this is, sorry, this is not insert. This is append. When we are doing insert, then it is, insert is how much? O of n. Because we have to shift the elements. This we have discussed yesterday also. If you are inserting in an array, if I'm having 10, then I'm having 20, then I'm having 30, then I'm having 40. If someone is saying that I want to insert 50, but I want to insert here, then what will happen? 40 has to come here, 30 has to come here, and then 50 will come here. So 40 will have to shift here, 30 will have to shift here, and then 50 will have to come here. So we have to shift. So this becomes O of n. Similarly, deleting also will be O of n. If you want to delete also something, then also it will be O of n. Because we have to shift the elements. Did all of you understand append, insert, and delete? Batao bhai, yes or no? All of you are clear? Now we'll talk about one more concept. So till now you will having, you might ask me one question, okay, that sir, you are saying that arrays, okay, they are having homogeneous nature and each memory cell has same size. Okay, this thing I'm not able to digest. Why? Because when we create a list in Python, suppose we are creating a list of marks. Okay, do we care about whether it is homogeneous or not? We can store like this also. We can say 10 also, and then we can say 15 also, and then we can say 100.28 also, and then we can say 40 also. And if you are having some issues, if you are having some problem, if you're not maintaining this, then you can also have some string also here. So if you imagine this to be stored in an array, then this will violate the definition of array, because if you store 10, this will be 4 bytes. This 15 will be 4 bytes, but this will be 8 bytes. So if this is stored, 10 is stored here, 15 is stored here, then 10 100.28 will be stored in these two memory locations because it is taking double the size. And NA also cannot be stored here because NA will also take equivalent number of, means different number of size. So this cannot be array. Then how is list working as an array in Python list? Did you guys have this doubt?
But it could be a list of list.
It can be list of list also.
So list of list, it will contain the address of that list.
Okay.
This cell, and that list will contain itself the different memory location.
Correct. What is it called?
Linked list.
Not linked list. We will talk about compact array versus a referential array. Okay, so what happens in a Python list? When we create a Python list, if we create a Python list, suppose names. By the way, when we talk about Python, in Python we'll talk about that. First, let us do names. I'm saying names, okay? So names, I'm having names as maybe Manas, and then we are having Imran, and then we are having Saif. Okay, so if we want to create an array of Manas, Imran, and Saif, is that possible? Because Manas is having 5 characters, so definitely size of Manas is different. Imran is also having 5 characters, so it is different, but Saif is having 4 characters. So it cannot be stored in a list typically the way we are imagining. Although it is of the same data type, but our assumption that every cell has to have the same size. Is it possible? There are 2 ways in which it can be handled. One is using a delimiter and other is using a referential array. Delimiter means, we'll not talk about delimiter, that is how it works in C language, but we will talk about referential array. So what happens in referential array, which is the case in Python, is that Python, when we create a list in Python, okay, it does not store the data, the primary data. It stores reference to the objects in memory. And many times you will hear that Python is slower than C, Python language is not as fast as C. This is the reason. This is the reason why we say that. Okay. So what happens in C is that in C, whatever data you are storing, that is actually stored in the list. But in Python, the data is not stored in the list. Only a reference to the data is stored in the list. So what will happen when I'm creating this Manas, Imran, and Saif? What Python will do is Python will create this Manas inside one memory location. It will say this is Manas. And it will store another memory location. It will say this is Imran. And I will store another memory location. This will be Saif. Okay. Suppose this is in memory location 2000. This is in memory location 3000. This is in memory location 5000. And when we create a list, when you say this is names in Python, what happens is you will create a names in Python. How it is stored is it will store the reference. It will store this is reference 1, this is reference 2, and this is reference 3. So iska jo address hai, that address will be stored here. Reference 1. And iska jo address hai, that address will be stored here. That is reference 2. And iska jo address hai, that address will be stored here. This is called as reference 3. Did you guys understand? What is the difference between compact array and referential array?
So it happens always, or in case of the different
Always.
data type?
Python list always.
Sir,
That's why you have a freedom of storing whatever you want.
but this reference values, are they contiguous?
No. Why will it be contiguous? This will be contiguous.
That's what I'm saying. Yeah.
This reference will be what? This reference will be some address, which is 2000, 3000,
no, it will be 2004,
8000. Right? So what you are doing in names, what are you storing? You are storing integer. This integer is stored in a contiguous fashion.
Right.
यहाँ पे एक array बन रहा है. Manas, what you are saying is 100% correct. Manas is saying that the actual memory is somewhere and not contiguous, but the reference value is contiguous address. So this reference hai, this reference is 2000, 3000, and 5000. This is stored in contiguous way. ये किसी memory location पे है. This memory location is maybe 12,000. This is maybe 12,004, and this is 12,008. I don't know if you are able to read the green color. Let me write it in white. This memory location is 12,000. This memory location is 12,004, and this is 12,008.
सर आपने कहा कि ये जो रेफरेंस यहाँ पे पाइथन के लिस्ट में ये रेफरेंस स्टोर करता है, बाद बाकी दूसरे लैंग्वेजेस में ये रेफरेंस नहीं, एक्चुअल क्या कहते हैं
डिपेंड
कि
करता है, डिपेंड करता है। जैसे जावा में एक एरे भी होता है और एक अरे लिस्ट बोल के शायद ऐसा कुछ होता है।
अच्छा
हाँ, सी लैंग्वेज में ऐसा नहीं होता, सी लैंग्वेज में डायरेक्ट स्टोर रहता है।
अच्छा ठीक है, सी लैंग्वेज में अगर डायरेक्ट स्टोर रहता है
हाँ,
तो वहां
वो
पे अगर
इम्प्लीमेंटेशन पे डिपेंड करता है। हर लैंग्वेज में हर तरह का इम्प्लीमेंटेशन होता है। कॉम्पैक्ट एरे भी रहता है, रेफरेंशियल एरे भी रहता है।
तो उस केस
पाइथन
में
में बाय डिफॉल्ट रेफरेंशियल एरे रहता है।
अच्छा ठीक है, अगर सी लैंग्वेज में हमारा एक्चुअल वैल्यू स्टोर करता है तो उस टाइम पे हम सेम होमोजीनियस डेटा ही स्टोर कर सकते हैं।
होमोजीनियस डेटा ही स्टोर कर सकते हैं, लेकिन उसका तरीका अलग होता है। उसमें क्या होता है, सी लैंग्वेज में क्या होता है कि इस पे डिटेल में मैं नहीं जाना चाहता हूँ, लेकिन उसमें क्या होता है ना कि जैसे आपको ऐसे स्टोर करना है, सपोज मैं हाई लेवल बता रहा हूँ, ठीक है। सपोज आपको ऐसे स्टोर करना है मानस, उसमें डिलिमीटर यूज होता है, मैंने बताया ना अभी। सपोज आपको ऐसे स्टोर करना है मानस और आपको स्टोर करना है सैफ, ठीक है। तो ये एरे में ही स्टोर होगा, एक मेमोरी लोकेशन में ही स्टोर होगा, ठीक है। लेकिन उसमें हम ये बताते हैं कि कहाँ पे कौन चीज स्टार्ट हो रही है और कहाँ पे कौन चीज एंड हो रही है, ठीक है। तो जैसे मानस स्टार्ट हो रहा है, तो यहाँ पे एक स्टार्ट का कुछ इंडिकेटर रहता है, एक डिलिमीटर रहता है कि स्टार्ट है, ठीक है। उसके बाद एम स्टोर रहेगा, ए स्टोर रहेगा, एन स्टोर रहेगा, ए स्टोर रहेगा, एस स्टोर रहेगा। जब ये माइनस खत्म हो गया तो यहाँ पे एक इंडिकेटर रहेगा एंड, फिर यहाँ पे इंडिकेटर आएगा स्टार्ट, फिर यहाँ पे एस रहेगा, फिर ए रहेगा, फिर आई रहेगा, फिर एफ रहेगा। अब ये होमोजीनियस है बिकॉज एम ए एन ए एस दीज आर ऑल होमोजीनियस। दे
हाँ
विल ऑल
क्योंकि
टेक
ये 4 4 बाइट
4 4 बाइट या 1 1 बाइट, जो भी जितना भी लगना है, ठीक है।
और
और
ये
फिर
कंटिन्यूअस है।
और कंटिन्यूअस है, फिर यहाँ पे एंड आ जाएगा, फिर नया वैल्यू आप डालो, फिर यहाँ स्टार्ट आएगा, फिर यहाँ पे आप नेम डालो, ऐसे करके वो चलता रहेगा। तो डिलीमीटर यूज करके ये
गॉट
डेटा एक्चुअल में स्टोर रहता है। तो जब सी उसको रीड करेगा तो सी देखेगा अच्छा स्टार्ट मिल गया, इसका मतलब मेरा स्ट्रिंग स्टार्ट हो गया। उसको रीड करता जाएगा जब तक उसको एंड ना मिल जाए। एंड मिल जाएगा तो समझेगा कि अच्छा मानस हमने रीड कर लिया, अब सेफ को रीड करो। तो अच्छा स्टार्ट मिल गया, फिर एस ए आई एफ ऐसे रीड करेगा, एंड मिल गया तो उसको खत्म कर देगा। तो इस तरीके से ये स्टोर रहता है।
इट मींस हम स्ट्रिंग में डिफरेंट लेंथ का डेटा स्टोर कर सकते हैं बट द टाइप शुड बी होमोजेनियस।
हाँ, मतलब स्ट्रिंग है तो वो होमोजीनियस ही होगा ना।
हाँ
स्ट्रिंग का जो इंडिविजुअल एलिमेंट्स है वो एक कैरेक्टर होगा। वो एक कैरेक्टर तो बराबर स्पेस लेगा, चाहे वो कोई भी कैरेक्टर हो।
समझा।
इंटीजर हुआ तो अलग लेगा, फ्लोट हुआ तो अलग लेगा, स्ट्रिंग हुआ तो अलग लेगा, बुलियन हुआ तो अलग लेगा। लेकिन अगर बुलियन है तो सिर्फ बुलियन रहेगा। अगर क्यों क्यों ऐसा जरूरी है, ताकि इंडेक्सिंग तभी तो हो सकती है ना जब हमें ये पता होगा कि एक ब्लॉक कितना है, तभी तो आप इंडेक्सिंग कर पाओगे ना। अगर हर ब्लॉक अलग अलग हो गया तो आप इंडेक्सिंग ही नहीं कर पाओगे। इसीलिए होमोजेनिटी इंपॉर्टेंट है। बट दिस यू डोंट हैव टू वरी, दिस यू डोंट हैव टू वरी एट ऑल। ओके, दिस इज नॉट अ पार्ट ऑफ व्हाट वी हैव टू अंडरस्टैंड। What we have to understand is the referential array. Referential array, all of you understood. In compact array and referential array. Okay, so here actual data is stored in contiguous memory. Here reference of data is stored in contiguous. So yesterday someone was asking me that how list is working in Python. So list, and what is the connection between list and array? So list is also an array, but it is an array of the address of individual elements. Okay, so here access will be fast. We will say here there is no pointer in direction, and therefore it is fast. Here there is pointer in direction. What is the meaning of pointer in direction? that if you want to read an element, you have to first go and read the address. Then you have to go to that address and then read it again. So you get the actual data. So 2 times you have to indirect. Did you guys follow? Saif is saying, how does referential array get to know how many elements would it get? मतलब जितना आप इनिशिएट करोगे उतना वो लेगा, और डायनामिक एरे के कॉन्सेप्ट के हिसाब से उसका डबल लेके रखेगा. जब आप अपेंड करोगे तो अपेंड करता जाएगा. जब वो बफर आपने लिया वो खत्म हो जाएगा तो वो एक नया ब्लॉक ऑफ मेमोरी ले लेगा. जो भी एरे का कॉन्सेप्ट हमने पढ़ा वही एरे का कॉन्सेप्ट होगा. बस आप जो स्टोर कर रहे हो वो डेटा के बजाय आप डेटा का एड्रेस स्टोर कर रहे हो. यही हो रहा है बस. Manas is saying, so implementing wise from programming perspective, it becomes simple, but performance wise compromise. Correct. Absolutely. That's why people say no, that Python is slower and C is faster.
Can you please share some use case where we use the referential array?
All the time. Python में जितना हमने कोडिंग किया है, जहां पे भी हमने लिस्ट बनाया, हर जगह वो रेफरेंशियल एरे ही था. जब आप डेटा साइंस पढ़ोगे और आप नमपाई पढ़ोगे, नमपाई भी अरे होता है, लेकिन नमपाई कॉम्पैक्ट अरे होता है. इसलिए जब आप नमपाई अरे पढ़ोगे तो नमपाई में यू विल नॉट बी एबल टू क्रिएट numpy array with multiple data types. It will always be homogeneous. But Python list is referential. Python, so if you talk about, so here there is one more thing, which is yesterday somebody was talking about cache. So here, this is cache friendly. What is cache friendly? Cache friendly basically means that if you are dealing with some memory location, okay, if you're dealing with some memory location like this, suppose this is 10, 20, 40, 60, 80, 90. Suppose this is your array. Okay, so if your CPU is reading 40, then CPU will also take agal-bagal ka element 20 and 60 and 80 and 10, and it will say कि 40 तो user ने मांगा है, लेकिन अगल-बगल का element also let me take and let me keep it in case it is needed. Because it is contiguous and it is in memory proximity, because it is contiguous, that's why it is cache friendly. So what happens in memory? In memory also, like I told you, there is a storage. Storage is slow. Memory is fast. But within memory also there are levels. There is L1 cache, L2 cache. Then there are some CPU registers. So in that also there are levels. When CPU is trying to read data, it is not directly going to memory also. It is first checking in the first cache, then second cache, then third cache. If it is not finding, then it will go to the actual memory. So when you're trying to read something, what CPU will do? It will take adjacent values and it will store it in a further subsector of the memory from where it can get it even more faster. So because in an array, in a compact array, the data is actually in contiguous memory location. That's why it is easy to cache it. You can cache the entire thing once. So it becomes even more faster. But what happens in a referential array? Data is actually not contiguous. Okay, so if you want to store this 10 will be somewhere, 20 will be somewhere, 40 will be somewhere, 60 will be somewhere, 80 will be somewhere, okay, and 90 will be somewhere. Okay, and then we are creating an array like this. 1, 2, 3, 4, 5. And ये 10 का जो memory, 10 का जो address है, that will be here. And this will be here, this will be pointing to this. This will be here pointing to this. This will be here pointing to this. This will be here pointing to this. And this will be here pointing to this. So even if you cache some part of the memory, it is not helping you. Because you are only getting the address. Anyway, you have to go to the memory and read it. So this is not cache friendly. Actual only address is contiguous. Did all of you understand? See, these are theory parts. This is not very needed for your interview perspective. Nobody is going to ask you all this. But understanding of array is important. Okay, these things are important. Okay.
Also, does this referential array concept is similar to the pointer concept in C?
You can say that. No proximity in actual data. Therefore, not cache friendly. Now, somebody was constantly asking me about shallow copy, deep copy, and all that. Okay, so you see what will happen. Because this is references. What happens because you are using references? So what happens is, again, keep this concept in mind. This will be important for you. Okay, that suppose you're creating a Python list. Okay, this is 20, this is 30, this is 40, and this is 50. So actually, you know that in memory location, marks list is not actually 30, 40. It is actually 20, 30, 40, 50. This is actually only storing the address of 20, 30, 40, 50. These are individually stored somewhere. And this is only storing the memory of this. Sorry, address of this. Okay. So when you do in Python, when you do that, if you do like backup is equal to marks list. Backup is equal to marks list. So what it will do? Marks list is what? It is an array of references of 20, 30, 40, 50. Correct? So if you create backup is equal to marks list, then marks list also is what? This is also one array with memory location of 20. This will be also 30. This will be also 40. And this will also be 50. So when you're creating a copy like this, guys, are you following? When you're creating this marks list like this we will say this is a shallow copy. Because it is not creating a new list. It is only, the data is still the same. Data is still the same. This is only pointing to the same item which was there. If you are assuming, what we are thinking in mind, what we are doing, we are thinking that this was marks list. So this was pointing to 20, 30, 40, and 50. And then when we create backup, so backup is also like this, which is 20, 30, 40, 50. It's not like that. It is not again creating the elements. It is pointing to the old one only. If you do this way, then it is called as a deep copy. So normally we don't do deep copy. We do shallow copy. When you are running this line, this is a shallow copy. Marks list and backup. So this you have to keep in mind. If you want to do deep copy, there is a module in Python. You have to import copy.deepcopy, then you have to do. If you want proof of this, you can see the proof. Okay, if you want proof of dynamic nature, that also I can show you. Okay. See, this is what I was saying. When we are learning about array, we are learning some academic things and we are also learning problem solving patterns. So right now we are not learning problem solving patterns. We are just learning about array. Okay. So in a way, if you don't know these things, then also you are able to solve the problems. Okay. And if you don't know how to solve the problems, then also you can learn this. So these are two separate items, but if you're learning programming, you should know these things. That's why I'm covering it. Okay. We'll get to problem solving patterns also. So if you do shallow copy, deep copy, suppose if I'm doing marks, okay, and I'm saying 10, 20, 30, and 40. Okay. Able to see this? So if I do marks of 0, okay, and if I want to find out the memory location of this, I can do ID. So this will give me, this is the memory location. Okay. Similarly, I can take this. This part you should know. Deep copy, shallow copy you should know, because sometimes otherwise you will make some mistake. Okay. I can do 2 and I can do 3. Okay. You can see these are the memory locations of 10, 20, 30, and 40. Now if I do backup of marks, okay, and I do the same thing here. You see this location is same. 433 991 9496 9496 9816 9816 0136 0136 0456 0456. Now if I make any change in backup, because backup and marks are pointing to the same location. So if I change that location using backup, marks will also get affected. So if you see, if I do backup का -1, if I say this is 1000, suppose, तो अभी क्या हो रहा है? यहाँ पे क्या हो रहा है? यहाँ पे 10 है, 20 है, 30 है और 40 है. Sorry, this will not work here. Sorry, this is a wrong example. Okay, because this is immutable, it will not work. We'll take that example also. So this is my marks. This is also pointing here. Okay, and if this is backup, this backup is also pointing here. Okay, so here what will happen, because these are integers. Okay, these are integers and integers are immutable. Let me explain this. Let me explain this. This is important. Okay, this you have to pay attention. There are two cases here. Okay, one is that if elements of list are immutable, okay, making change in copy makes no difference. Okay, but if, how many of you are understanding what I'm saying, this part? If elements of list are mutable, then making change in copy will affect the original. This you have to keep in mind. What is the meaning of this? Can someone explain? What I meant by this?
So mutable means it can be edited.
Edited, ठीक है?
So if I am making a copy of it, then obviously if I'm making changes, the copy is actually referring to the older elements only.
Okay.
तो अगर editable है तो older elements change ही हो जाएंगे.
Change हो जाएंगे, सही बोल रहे
Change हो जाएंगे, और immutable है तो editable ही नहीं है. तो
editable ही नहीं है, तो उसको जब हम change करेंगे तो क्या होगा?
तो ideally speaking, it should create a new set of
Correct.
memory.
Correct.
And उसमें
इसको एक
वो add-
example से, correct, what you are saying is correct. So suppose if you are having marks here, which is restoring 10, 20. Let me make it here. This part is important. This you have to understand. Okay. Saying 10, 20, 30, and 40. So you are having one array here. And this array is such that it is pointing to this memory location. Okay. And if you're creating a backup is equal to marks. This is a shallow copy. Okay. So shallow copy है तो क्या होगा? You will create here, and here also you will have some references. This reference will also point here. This will also point here. This will also point here, and this will also point here. So here, if you do that backup -1 is equal to 100, what will happen? Backup of -1 को 100 बनाना है, तो we will create 100. Okay, we will create one instance of 100 in some memory location, and backup का जो last वाला जो pointer है उसको हम लोग यहां से हटा के यहां पे डाल देंगे. There is no problem. Correct, no? Can we try this? What I'm saying, if it is making sense or not. If I say backup 1 is equal to -100, now if I do marks, क्या हो गया? कुछ गलत बोल दिया क्या मैंने?
सर वो एक चीज समझ में नहीं है, वो बैकअप में -1 क्यों लिख रहे हो सर?
कहाँ पे?
बैकअप के इंडेक्सिंग में आप -1 क्यों लिख रहे हैं?
-1 क्यों लिख रहे हैं मतलब?
आप लास्ट एलिमेंट को पॉइंट आउट करना चाहते हैं क्या? तो कोलन एंड -1 होगा ना?
क्यों?
मतलब मैं ये सोच रहा था कि यू वांट टू पॉइंट आउट एट द लास्ट इंडेक्स और द लास्ट एलिमेंट ऑफ द लिस्ट.
लास्ट एलिमेंट है तो -1 ही लिखेंगे ना.
बट वो कोलन और फिर -1 लिखेंगे ना?
नहीं, कोलन -1 लिखेंगे तो वो स्लाइसिंग हो गया ना.
ओके ओके.
अगर आपका मार्क्स ऐसा है, टेन, 20, 30, 40. If you do marks -1, this will give you 40. If you do marks -1 colon, this will give you what? This is a slice.
Yeah, okay.
This is indexing. This is slicing. Khair, this is not what we were doing. मैं यहाँ पे शायद उल्टा बोल दिया मुझे. एक मिनट रुक जाओ. कॉपी से अलग होता है क्या? एक मिनट। Backup is pointing to marks. अच्छा, इसको बाद में डिस्कस करना है। तो शायद कॉपी और इसमें मैं थोड़ा भूल गया हूँ। ये तो शैलो कॉपी होता था। एक में चेंज हो रहा है, एक में चेंज नहीं हो रहा है। अच्छा नहीं, दोनों में चेंज हो रहा है। This is expected. Give me 1 second. Let me Google it. I think I got confused somewhere. अच्छा, इसको कल डिस्कस करते हैं, नेक्स्ट क्लास में डिस्कस करते हैं, ठीक है? आई थिंक आई गॉट कंफ्यूज्ड इन दिस वन समवेयर. We'll leave it, okay? We'll leave it till here. We'll discuss because storing in memory. It should actually create a new memory location and store it there. In the same memory location, if it is adding. ठीक है, चलो इसको डिस्कस करते हैं, आज यहीं रहने देते हैं, ठीक है? ये मेमोरी वाला लोकेशन विल दिस म्यूटेबल इम्यूटेबल पार्ट वी विल डिस्कस लिटिल बिट लेटर. ओके, we'll stop here. We have discussed arrays, okay, and most of the concept around arrays we have discussed: dynamic array, referential array, compact array. Everything we have discussed. Tomorrow what we will do next class, we'll cover this part. I will clarify this, and then we'll start with problem solving patterns on arrays. Okay. So here what we will do, we'll do some basic questions. Then we will start with two pointer approach. So two pointer approach I have already shown you. Okay, but we'll do some more questions. Two pointer approach. Then we will do sliding window. Okay. Then we will do array plus set or dictionary. And there are some questions which are sorting based. And there are some questions which are interval based. And there are more patterns also. Okay, I'm not saying that these are the only patterns, but these are the most common patterns. Okay, these are the common patterns that we will cover. Okay, sorting based we will maybe do little bit later, because when we do algorithms, that time we will discuss different types of sorting. Okay, so but mostly we will focus on two pointer approach and sliding window approach. There is one more thing I forgot here. स्लाइडिंग विंडो के साथ में we will do prefix sum. Based, one more thing I forgot. We'll do Kadans algorithm. Okay, these many concepts we will do. So mostly maybe in one class or two class we will try to do. So we'll try to do 1, 1, 2, 2 questions of each of these patterns. But in terms of basic understanding of array, I think whatever introduction I had to give, I've given. Only this referential वाला part थोड़ा सा मैं clarify कर लूँगा, पता नहीं मैं कहाँ confuse हो रहा हूँ. Then we will close our array discussion. Then we will start with linked list. ठीक है? Other than this last part, is there anyone having any other question? इमरान सैफ इज सेइंग कॉपी करने से नया एड्रेस आसान. ठीक है, वो कॉपी वाला मैं बताता हूँ, मुझे खुद समझ में नहीं आ रहा. Can we discuss next class? I have to AIML. Imran, you can leave if you want. Okay, no problem. Can you share some homework for this week? Homework, I will share some questions. Okay, some basic questions on arrays. I will give you one sheet, DSA sheet. In that DSA sheet, we will keep tracking what are the questions we are solving. Okay, so pattern wise, I will add some question and I will give you those sheets. Okay, let me prepare that. Maybe in 1 or 2 days I will give you. इस वीक में कुछ असाइनमेंट्स मिलेगा. असाइनमेंट बहुत सारा मिलेगा आपको. बेसिकली असाइनमेंट आपका होगा लीड कोड क्वेश्चन सॉल्व करना और कुछ नहीं. टाइलर सिंह टॉपिक शैलो डीप कॉपी ये पढ़ता हूँ मैं. ठीक है, एनीवन एल्स?
फिर इसमें आपने एक इंसर्शन एंड डिलीशन में इसके केस में दोनों में कॉम्प्लेक्सिटी ब्लॉक बिग ऑफ एन लिया था.
कहाँ पे?
जस्ट अबव इंसर्शन एंड डिलीशन एंड अपेंड वाले केस में, जो अमोर्टाइज वाला केस था, उसके वहां जाओ.
हाँ, एक मिनट ढूंढने दो, कहाँ है?
ये डेटा स्ट्रक्चर और एल्गोरिथम में कुछ कंटिन्यूटी है क्या उसमें? डेटा
हाँ
स्ट्रक्चर
हाँ,
एल्गोरिथम
एक
सेम ही है ना?
मिनट सर, एक मिनट सर. हाँ, क्या अपेंड इंसर्ट
एक
में क्या बोल रहे थे?
जैसे कि इंसर्ट है. इंसर्ट अगर हमें लेट्स से ऑन लास्ट में करना है, उस केस में भी हमारा
इंसर्ट अगर आप लास्ट में करोगे तो वो अपेंड हो जाता है.
उसका वन हो गया. ठीक है. और अगर हम करते हैं इन बिटवीन, तो हमें शिफ्टिंग डिपेंड करता है कि उस प्लेस पे कितना है. तो हम हर एक केस में शिफ्टिंग एन ही लेंगे, इसलिए हमें सिंगल लास्ट में करना है इंसर्ट.
हाँ, हम लोग वर्स्ट केस लेते हैं.
तो उसमें सिर्फ सिंगल एक शिफ्ट होगा, राइट? अगर हम
सिंगल एक
second
शिफ्ट
last
नहीं
में
होगा. सिंगल एक शिफ्ट नहीं होगा. सपोज आपको ऐसे इतना बड़ा एरे है
जी,
और आपको कोई एलिमेंट अगर यहाँ पे स्टोर करना है,
यहाँ पे फिर हाँ, इसके बाद जो भी सारे एलिमेंट आपके शिफ्ट होंगे
उसके बाद
राइट में.
जितने एलिमेंट्स होंगे, सपोज ये इसका टोटल जो लेंथ है वो n है
जी
और आपको kth पोजीशन पे करना है. ठीक है, तो n माइनस के एलिमेंट्स आपको शिफ्ट करना पड़ेगा.
जी.
ये वाला
Okay.
यहाँ जाएगा, ये वाला यहाँ जाएगा, ये वाला यहाँ जाएगा, ये वाला यहाँ जाएगा. अगर आप यहाँ पे कर रहे हो
जी
तो आपको सिर्फ एक ही एलिमेंट शिफ्ट करना पड़ेगा. और अगर आप यहाँ पे कर रहे हो तो आपको बहुत सारे एलिमेंट शिफ्ट करने पड़ेंगे. तो आप कहाँ पे इंसर्ट कर रहे हो उस पर डिपेंड करता है कि कितने एलिमेंट्स शिफ्ट होंगे. बट वर्स्ट
बट
केस में n होगा, तो हम लोग हमेशा वर्स्ट केस की बात करते हैं.
एंड सिमिलरली फॉर डिलीशन आल्सो, अगर हम जैसे कि अगर लास्ट में डिलीट कर रहे हैं तो सिर्फ एक सिंगल डिलीट हुआ.
हाँ, तो एक्चुअली डिलीट में भी दो केस होता है. एक होता है
हाँ
डिलीट, तो हम
जी.
लोग जब डिलीट बोलते हैं तो जनरली हम लोग बीच का एलिमेंट बोलते हैं. लास्ट एलिमेंट को अगर हम डिलीट कर रहे हैं तो उसको हम लोग पॉप बोलते हैं.
ओके.
पॉप बोलते हैं, तो पॉप भी O ऑफ 1 में हो जाता है. लास्ट वाला हमें अगर हटाना है ना तो वो पॉप हो जाता है O ऑफ 1 में. डिलीट जब हम लोग बोलते हैं तो जनरली डिलीट मतलब बीच का कोई एलिमेंट डिलीट बोलते हैं या रिमूव बोलते हैं.
और बाकी हम इस इंसर्ट और डिलीट को लॉग इन नहीं कर सकते किसी भी केस में ना. इसे कम नहीं, मतलब
एरे में
पॉसिबल
नहीं कर
नहीं.
सकते, एरे में नहीं कर सकते.
ठीक है सर, थैंक यू।
एरे में नहीं कर सकते, लेकिन कुछ स्पेशल केसेस में कुछ स्पेशल केसेस में हम लोग कर सकते हैं, तो वो हम लोग देखेंगे आगे चल के। कुछ डेटा स्ट्रक्चर्स में जब हम इंसर्ट करेंगे तो हम उसको एक बेटर तरीके से कर सकते हैं, अगर वो जैसे अगर वो सॉर्टेड हो, तो ये हम लोग मान के चल रहे हैं कि ये अनसॉर्टेड है बाय डिफॉल्ट। लेकिन अगर इस पे कुछ कंस्ट्रेंट्स लगा हो या इसको एक तरीके से बनाया जाए दूसरे डेटा स्ट्रक्चर्स में, जैसे प्रायोरिटी क्यू होती है, हीप होती है, उनमें जब हम इंसर्ट करेंगे तो हम लॉग एन में कर पाएंगे। बट एक जो डिफॉल्ट एरे है, जो लो लेवल फंडामेंटल एरे है, उसमें नहीं।
ओके, अंडरस्टूड, थैंक यू सर।
Guys, I'm having one idea. Okay, I don't know if you guys will will be interested. I'm just thinking. Guys, by the way, class is over. Okay, those who want to leave, you can leave. So what I'm thinking is I want to start one series. Okay, the class is going on, that is fine. But other than class, I'm thinking that once in a week we can have one extra class where we will sit and solve some problems separately. So will you guys be interested in that?
तो
एक लाइव सेशन
Yes.
करेंगे, ठीक है? मैं अपने चैनल पे करूंगा, यूट्यूब चैनल पे। वो ओपन फॉर ऑल रहेगा, लेकिन अभी मेरा जो ऑडियंस है वो आप लोग ही हो, ठीक है? तो अगर आप लोग आओगे तो जो भी टॉपिक हम लोग पढ़ रहे हैं ना, उस टॉपिक के ऊपर हम लोग कुछ नया कुछ भी नहीं डिस्कस करेंगे, लेकिन जो टॉपिक पढ़ रहे हैं उसका हम लोग वहां पे प्रैक्टिस कर लेंगे क्वेश्चंस को।
तो इसमें ऐसा
इसमें ही
पॉसिबल है
करेंगे
कि
क्या?
जस्ट लाइक आप जो क्वेश्चन सॉल्व करें वो ऑलरेडी मतलब इंटरव्यू में पूछे हुए हो, तो वो ज्यादा बेटर हमें आई थिंक एक लगेगा। लाइक
पूछे हुए क्वेश्चंस यू कैन फाइंड इट ऑन लीड कोड। सी द थिंग इज दैट questions whatever we will do on lead code, those questions are commonly asked. Other than that, if there is any other question, that will also be somewhere twisted but on the same concept. So you can do company wise questions, you can do, but you should do that once you have already achieved some base. So what, when we do lead code question only, when we do lead code, first we do basic questions, then we do slightly, if so, for example, right now today it took me so much time to explain binary search. But and tomorrow it will take me more time to explain sliding window. But once I explain sliding window and I explain binary search, then remaining things we can do little bit fast. So company wise questions don't bother at this point, bother after maybe 2 months from now, because slightly difficulty will be higher in that.
So once extra
But
class,
I will try that also in lead code. If you take lead code premium, then you will be able to see company wise questions also. But first, let us do basic questions. If you have said today we have learned binary search. Okay. So the strategy is that first we should master binary search. Our tool should be ready. Then when you are solving a bigger problem in which binary search is being used, then immediately you should be able to use it. But if you are not confident in binary search only, then you will not be able to use it. So first we have to do basic questions. So every topic, there are some 4 or 5 basic questions that are must solve. If you do that, then it will come to around 125 questions total. After that, 60-70 questions you have to solve, which will be slightly company wise. So that will come approximately 200 questions. So once you are done 200 questions, then you will be confident. I'm not saying 200 questions is sufficient, but if you have done 200 questions, then you will not need help from anyone else. You will yourself know what is the ground and what I should do. But if you don't know the basic concept, no, then what will happen when you are solving a lead code question? You will spend time on that, then you will not understand it, then you will go and look at the solution. You will look at the solution and you will solve it, and after 5 days you will forget it. Again that question will come, you will not be able to solve it. That's why then people will say that, sir, we have solved 500 questions, still we are not able to solve new questions. That is because the basic questions you have not spent time and you have not digested it properly. If you are digesting properly, then even 200 questions is sufficient. but those 200 questions you will have to solve 2-3 times. Because once you solve it, today you are learning about dynamic programming, okay? Then you solve 10 questions. Then you will move to a different concept. You learn about backtracking. Then you are solving 10 questions on backtracking. Again, you will go back to dynamic programming. No, you will forget everything. So again, you have to solve that. And then again, you have to solve that. So 2 to 3 times we have to do like revision of whatever we have learned. So it's a long journey, okay? Don't think that it is some shortcut. We will do some 100 questions we have solved and then we are ready. It's not like that. Even when I'm saying you have to solve 200 questions, those 200 questions you will have to solve 2 times, maybe. That makes it 400. So don't be in a hurry. We will do, even after the course is over, I will be available for you all the time. Okay. But right now what I'm thinking is we are doing class whatever, but let us do more problem solving. So separately outside of the class, we will do in the class also everything. But suppose I'm giving you assignment. Those assignments is not possible to discuss in class, but we can do separately. So if you guys are okay, then I can start such a thing. It's just an idea, one proposal I'm giving to you.
Yeah, we can do it, sir.
Okay, and it will be recorded. It will be there. So if you are not there, whenever you want, it will be like a reference for you. That's all.
Yeah.
An additional like kind of a additional resource.
Yeah,
That is one thing, and we will also have to do extra classes on our course also, because 2 classes were gone in Diwali, and the pace at which we are going, it is little bit slow, so we have to move little bit fast also. So I will have to request some extra classes here also, and some not extra classes, you can say some additional separate material on some live sessions we can do.
Yeah, we can do it on Wednesday or something at 8 o'clock or something.
Yeah.
8 p.m.
So
Yeah.
that way, I mean, even after the course is over, we can continue our journey of learning. So I will also, every day I try to solve one question. So I will solve it along with you guys, so that every day, like, half an hour you will spend. So that way we can be connected.
Sure.
And can you provide at least that lead code that base to 200 question starting?
I will give you. There is one
at
sheet.
least-
There is one sheet. I already have one sheet I've created, but I will create separately for you. This is one sheet, is not this one.
वो इस वीक के लिए कुछ दे दो सर।
I will give you. I'll give one. I will create. ये sheet है ना यहाँ पे?
ठीक, इसी से निकाल के दे दो।
हाँ, ये शीट नहीं है, ये मेरा चैनल का शीट है, बट आई विल क्रिएट वन शीट लाइक दिस। यहाँ पे कैटेगरी वाइज है। आई विल क्रिएट दिस थिंग, व्हाट डू से, पैटर्न वाइज आई विल क्रिएट वन मोर शीट, या यहीं पे मैं एक दूसरा बना दूंगा, एंड आई विल स्टार्ट कोलेटिंग क्वेश्चंस इन दैट। आई विल गिव यू क्वेश्चंस इन दैट, यू कैन सॉल्व दोस
कैटेगरी वाइज भी
क्वेश्चंस।
बना सकते हो?
कैटेगरी वाइज ही
जैसे-
बना के मैं दे दूंगा।
ओके,
ठीक।
या ये वाली शीट भी आप ले सकते हो, ये वाली शीट भी मैं डाल देता हूँ चैट में। इसमें मैं एरे से रिलेटेड क्वेश्चन डाल दूंगा, तो यहाँ पे कुछ एरे के क्वेश्चन मैंने यहाँ पे डाला हुआ है, तो वो एरे के क्वेश्चन आप ले सकते हो। कहाँ पे है चैट? ये वाली शीट भी आप फॉलो कर सकते हो, ठीक है। लेकिन इसमें मैं ऑलरेडी कुछ क्वेश्चंस को डन मार्क कर दिया हूँ। ये मेरे चैनल का शीट है। आई विल क्रिएट वन मोर शीट फॉर दिस बैच। आई विल क्रिएट वन मोर
ठीक है सर, वो आप व्हाट्सएप पे अपडेट।
WhatsApp में डाल दे।
व्हाट्सएप पे, हाँ, वो लिंक मैं व्हाट्सएप पे डाल दूंगा।
Sir, when you are planning for this, like timing and any from
I
your
will tell
side?
you. I will also have to plan, but mostly I will try. Maybe you tell me what time you guys will be comfortable.
After
Middle of
office?
the week.
वो शाम को ही होगा सर।
हाँ, शाम को ही obviously. I also have work, no, so I also will do it in evening only, or I can do it in morning also.
या मॉर्निंग
9 से पहले कर सकते हैं, फिर
हाँ।
9 से पहले खत्म करना पड़ेगा तो।
हाँ, 9 before 9 we can finish it. Early morning also we can do.
हाँ ठीक है, चलेगा।
या अर्ली मॉर्निंग इट विल फाइन।
कितने
हाँ,
घंटे
that's
का
what.
रहेगा उसको
How many
प्रोग्रामिंग में?
people?
Like 1
8
hour
से
like
9,
8 to
7।
9.
हाँ कर सकते हैं, 7 से 9 के बीच में कभी भी।
We'll do one hour, but the thing is 1 hour I also have to prepare that what we will do, because it cannot be free flowing. We're doing 1 hour, then I have to plan which question to solve, how much, like that. So we will do. Let us do this week. Next week, let us plan one. We'll do one trial how it goes. I have also not done it, so it's first time for me also. That's why we'll do
और
some.
ये जो आपका लिस्ट है, इसमें सिर्फ लिंक लिस्ट दिख रहा है, उसमें बेसिक अरे और ये सब
सब कुछ
स्ट्रिंग
है
का
भाई, सब
क्वेश्चन
कुछ है,
नहीं
सब कुछ है,
है?
सब कुछ है, सब कुछ है अभी। मैंने बताया ना कि ये मैंने अपने चैनल के लिए बनाया है, मैं आपके लिए एक सेपरेट शीट बना दूंगा। मैंने अपने चैनल पे लिंक लिस्ट ही पढ़ाया है और स्टैक क्यू ही पढ़ाया है, इसीलिए यहाँ पे ये तीनों ही है। एरे भी इसमें डाल दूंगा मैं। आई विल मेक अ न्यू लिस्ट एंड आई विल गिव यू।
Also, sir, requesting you for your experience sharing session as well, अगर if you are comfortable.
मेरा क्या एक्सपीरियंस शेयर करोगे?
अरे सर, आपका गूगल पूरा है, पूरा लाइक वेरी हेल्पफुल
अरे
फॉर
वही
अस की
वही है,
तो
जो क्वेश्चन मैं
सुधांशु
बता रहा
सर
हूँ
के
यही क्वेश्चन पूछते हैं, यही क्वेश्चन सॉल्व करते हैं, और क्या। बस मेरा एक्सपीरियंस थोड़ा ज़्यादा है तो मेरा सिस्टम डिज़ाइन वो सब डिस्कशन होता है, मशीन लर्निंग डिस्कशन होता है। बट फ्रॉम अ डीएसए पॉइंट ऑफ व्यू वॉट एवर वी आर लर्निंग सेम थिंग ओनली। बट डिफिकल्टी कैन बी डिपेंड्स ऑन योर लक। डिफिकल्टी कैन बी वेरी ईजी समटाइम्स, यू आर लकी, वेरी लकी। इफ यू आर नॉट वेरी लकी देन इट कैन बी वेरी डिफिकल्ट also. Normally it will be medium level. But whatever question we are doing, you have to make sure that you don't memorize it. So we'll do that also. We'll discuss all that also.
ठीक है
like
सर।
how do you say you are using in your profile in a Google right now, or it is just for interview purpose?
See, it's not for interview purpose. It is for your knowledge purpose.
जी, yeah.
अब जब हम लोग कंपनी में काम करते हैं तो वहां जाके हम लोग कोई लिंक लिस्ट नहीं लिख रहे होते, वहां पे कोई रियल लाइफ प्रॉब्लम होती है, ठीक है। बट when we are learning about this linked list and all these things, it improves you as a programmer. That's all. Even if you don't know DSA, you can work for many years.
जी सर।
It's possible. But it is good to know these things. It will make you a better programmer, and it will not take much time. No, it will take 2-3 months, 4 months of grind. After that, once you find your rhythm, then you can continue 1 or 2 questions every day. You can continue like that. You can do. Mohammed Kunan is asking, can you show your lead code? I have not solved a lot of lead code questions here. I have solved very little lead code questions.
In
This
data set is,
course duration is showing for 2 months. So how long
Sorry?
will it take?
Sorry?
The course duration is showing on the platform as 2 months.
My
But how
target is
long?
to complete it before New Year.
Okay.
Okay, but the pace at which we are going and how much content we have to cover, depending on that, I am doubting whether I will be able to finish in 2 months or not. So we will increase the speed, because what happens, you see, today whole class went in explaining about binary search.
Yes, sir.
है ना, तो इस स्पीड से, और binary search is a relatively simple thing. So tomorrow if we will do a different algorithm, it will take time. So what I'm thinking is we will focus on dry run and basic concepts, and then problem solving we will keep separate. Like today we have learned binary search, we learned how to implement binary search. Now binary search के related binary search के application पे जो questions है, that I will
Yes.
give you as an assignment. But those questions also, let us solve it together, is what my proposal is.
Yes, sir. Yes.
That will
would be
solve two
good.
things. One is that we will solve it together. There will be discipline also. And if we schedule time, then we will make sure that twice in a week we are sitting and we are solving. So
Sir,
most important thing is discipline. So it will be discipline for me also, for you also.
yeah, we'll get confidence also. Yeah.
Yeah.
We'll get confidence also.
You will get confidence also. Thoda sa, if you are alone, then you will leave it. But if as a group we are learning, then it will be, we can motivate each other like that. That is my thought, at least in the beginning. Okay, once you find your rhythm, then you do your own thing. But in the beginning, if all of us are together working as a community, then it will be better for all of us.
सर वो
Yes, sir.
लीड कोड क्वेश्चन सॉल्व करके कुछ टेक अवे होता है क्या, मतलब सॉल्व तो
Take away
कभी
hota hai. Whenever you are learning any, whenever, see, the basic, that's how those questions are there. So a lot of people have already curated some questions. For example, if you go and you look for blind 75. So blind 75 is a series of questions. Okay. So what happens in this blind 75? These are list of questions. So what people are saying that if you solve these 75 questions, you will get a good understanding of all topics. तो इसमें कुछ डीपी का भी क्वेश्चन है, कुछ क्यू का भी क्वेश्चन है, कुछ लिंक लिस्ट का भी क्वेश्चन है. तो इफ यू सॉल्व दिस क्वेश्चन, यू विल गेट अ गुड अंडरस्टैंडिंग. सिमिलरली देयर इज नीट कोड 150. नीट कोड 150. Okay. So NEET code 150 is also one list of 150 questions. So usually what people do when they are learning about DSA, they will solve this NEET code 150. So here also there are blind 75 questions are included in this. Plus there are some more questions. So if you solve these 150 questions, what happens is you get some confidence that, okay, I have solved this many questions. You get a clarity of what you are supposed to do, which topic is weak, which topic you have to pay attention. You will not need much guidance from me or anyone. So these are some lists. So similarly, I have my own list that I have created, which I will share with you, but it will be same as matching this only.
सर जैसे क्वेश्चन एक सॉल्व कर दिया,
हाँ
अब क्या हमारा ऑब्जेक्टिव ये होना चाहिए कि मतलब और कि जितने भी तरीके से सॉल्व हो सकते हैं, जितने भी एल्गोरिथम लग सारे
हाँ
तरीके से सॉल्व करें उसी एक
हाँ
क्वेश्चन को
हाँ, जितना आपके दिमाग में आ रहा है, जो यू हैव रेड अ
बार बार
क्वेश्चन,
सॉल्व करें.
you have read a question, you have done the brute force, now think, okay, this is optimized solution, क्या हो सकता है, और भी optimized क्या हो सकता है. Then you go to lead code and you look at other people's solutions. For example, जैसे ये question है, longest palindrome substring, ठीक है, इसका मैंने कोई solution यहाँ पे लिख दिया suppose, ठीक है, यहाँ पे मैंने इसका कुछ solution लिख दिया, जो मेरा solution यहाँ पे accept हो गया, suppose ये मेरा solution है यहाँ पे, ठीक है, according to me this is working fine. So what I will do, I'll go to solutions and I will look at other people's solutions. Maybe I'll get some better solution. But what happens is, if you are solving this question, suppose longest palindrome, then related questions you will be able to, when question is given to you, you will be able to think कि अच्छा इसमें ये अप्रोच लगेगा, इसमें बाइनरी सर्च लग सकता है, इसमें तो हीप लगेगा, इसमें स्टैक लगेगा, इसको कहीं क्यू से सॉल्व होना चाहिए. So you will get some kind of feeling inside that, okay, this approach will be used in that question. That is the point of solving some questions from all the different topics.
ठीक है सर. और आज सर एक नोट्स वगैरह भी इसका कुछ चीट शीट या ट्रैक शीट वगैरह होगा ना, कि
नोट्स वोट्स क्या बनाओ, कोडिंग में क्या नोट्स बनाओगे आप?
मतलब इस तरह के पैटर्न अगर ऑब्जर्व हुए क्वेश्चन में तो ये सारे एल्गोरिथम्स हो
हाँ, तो
सकते हैं
वो आपको
implement करने.
करना है, आपको क्या करना है कि जैसे आपको आपने क्वेश्चन सॉल्व किया, तो मैं क्या करता हूँ कि मैं लिख लेता था यहाँ पे कहीं पे, अभी यहाँ पे नहीं दिख रहा है, बट यहाँ पे जैसे आई विल राइट सम कमेंट्स, so that when I'm reading it next time, then I will be able to understand what I'm doing. So that you have to do, what you do is you can create your own sheet, एक Google Colab sheet में somewhere, and you can write your solution, and then you can write your thought process, that this is what I thought, this were the edge cases, like that. You can write it. So you can do that for some 50 or 100 questions. After that, it becomes nature. You will not need notes. ऐसे notes बनाने का जरूरत नहीं है, but you can keep track of, okay, this is a pattern. This is dynamic pattern, dynamic DP pattern में top down approach, bottom down approach. You can create your own notes, but you have to do it yourself. Anyone else will give you will not understand that. It's your personal understanding kind of a thing.
और हाँ सर, वो एक्चुअली लास्ट मोमेंट में अगर रिवाइज करना है इतना
वही
सारा
रिवाइज करने के लिए. And again, when you are solving those questions, store it somewhere in a Google Colab. It's my suggestion that you store it in your Google Colab, and then when you have to revise maybe 4 or 5 questions, if you revise, you will get the hang of it.
got it.
Every pattern will have some template actually, like binary search का एक template है ना, कि दो पॉइंटर है, एक को मूव किया, ऐसे मूव किया, वैसे स्लाइडिंग विंडो का एक टेम्पलेट होगा, ब्रेथ फर्स्ट सर्च का एक टेम्पलेट होगा, डेप्थ फर्स्ट सर्च का एक टेम्पलेट होगा. तो वो टेम्पलेट बहुत बार दिमाग से निकल जाता है. इफ यू रिमेंबर द टेम्पलेट, देन यू विल बी एबल टू सॉल्व द क्वेश्चन. So what happens is, you get the question, you don't know what to write the first line of code, you get blank. So for that, you can create a list of all the popular templates and 1 or 2 questions, common questions from each template. When you have to revise, you can go through those. But if you're constantly solving, then you will not forget it. Every day you are solving one question, it will be within 3 months, it will be very good position you will be in. 2 questions every day, if you solve within 2 months, you will be in good position. When I say good position, I mean confident position. I don't mean that you are can clear any interview. I don't make any such promise.
Okay sir, thank you.
Okay guys, so I will share the sheet and then I will inform you. We will do some live sessions, okay, and it's optional for you. If you want to join, you can join. Otherwise, I will make sure the recordings are available for you. Any other question?
सर कहीं पे सुना था प्रूनिंग के बारे में. व्हाट इज प्रूनिंग इन डेटा स्ट्रक्चर?
प्रूनिंग? प्रूनिंग कहाँ सुना आपने, किस कॉन्टेक्स्ट में?
डेटा स्ट्रक्चर में ना, वही सुना था कि
डेटा स्ट्रक्चर में प्रूनिंग तो मैंने नहीं
प्रूनिंग
सुना.
तो उसमें होता है ना, मशीन लर्निंग में होता है
मशीन
ना,
लर्निंग में आपने
डिसीजन
सुना
ट्री
होगा,
में.
डेटा डिसीजन ट्रीज में होता है प्रूनिंग, रेगुलराइजेशन में, ओवरफिटिंग अंडरफिटिंग में होता है.
सर ये जो आपने कॉम्पैक्ट एरे और रेफरेंशियल एरेज के बारे में बताया, तो
हाँ,
रेफरेंशियल एरेज वुड ऑलवेज बी डायनेमिक इन नेचर, राइट? डायनेमिक एरे।
रेफरेंशियल एरे शुड बी डायनामिक इन नेचर। ऐसा जरूरी तो नहीं है कि डायनामिक इन नेचर होना चाहिए, लेकिन डायनामिक ही हम लोग यूज करते हैं पाइथन में। डायनामिक नहीं होगा तो
यस।
यूज करना बहुत डिफिकल्ट हो जाएगा।
हाँ।
तो
और
जितना हम लोग
कॉम्पैक्ट
देखते हैं
एरेज।
उतना तो डायनामिक ही होता है।
यस सर, और कॉम्पैक्ट एरेज स्टैटिक और डायनेमिक दोनों हो
दोनों हो
सकते
सकते हैं, हाँ।
हैं। ओके।
तो नॉर्मली जो हाई लेवल लैंग्वेजेस होती है उसमें आपको डायनामिक एरे ही मिलेगा।
हाँ
स्टैटिक
यस
एरे
सर।
मतलब सी लैंग्वेज वगैरह में मिलता है।
यस सर, हाँ सी प्लस में एरे को डिफाइन करने के लिए पहले उसका साइज
हाँ,
डिफाइन करना होता है,
हाँ,
तो वो कॉम्पैक्ट एरे है।
हाँ, उसको हम लोग स्टैटिकली टाइप्ड लैंग्वेज भी बोलते हैं। अगर आपको एक इंटीजर भी बनाना है तो आपको बताना पड़ता है कि एक इंटीजर है।
हाँ
पाइथन में ऐसा
एसटीएल।
नहीं होता है, वो रन टाइम में खुद
यस।
ही पता कर जाता है। उसको हम लोग बोलते हैं डायनामिकली टाइप्ड।
ओके। ओके सर।
तो वेरिएबल टाइप में भी वो डायनामिक नेचर लेता है, वो कंपाइलर खुद ही पता कर लेता है।
हम्म। ओके सर।
ठीक है, आज की कहानी खत्म करें। आप लोग मुझे बताना लाइव सेशन के लिए कौन सा टाइम सूटेबल रहेगा, तो विल डू वन ट्रायल, वन लाइव सेशन, विल सी हाउ इट गोस एंड आफ्टर दैट विल सी। ठीक है, चलो बाय गाइस।